All right, so let's check together the output of this application. So here our landing page. So it's a multi-tenant stock management platform where you can manage inventory at scale. You can start a free trial or sign in if you already have an account. So everything you need to run your business: product catalog, stock movement, team, and roles. So if you do not have an account, just click on get started or start your free trial in here. If you already have an account, just click on sign in. So here from the sign in, if you are, for example, if you log in as a platform admin, so you will be redirected to a dedicated interface where you can see the list of tenants, the status, all the information about it. You can deactivate, you can suspend the tenant, and do everything you need about tenants. So now if we log out and create a new account, so let's say, for example, CMP comp, for example, or Alibu CMP. Let's call it this way. And here, let's say, for example, Alibu_CMP. So the company email, let's say contact@cmp.com. Let me copy this one. And here, let's say John Doe. And here, let's say john.doe at, I don't want to allow this. And the password, let's say simply password. So now let's click on create account, and the account was created. So if I log in again as the platform admin, so, and here password, and I click on sign in. So all right, so we see here that we have the Alibu CMP, or the new company, listed in here. Once I approve this one, a new schema will be created in the backend. So here we see that we have 5 schemas, and also like I can remove or delete the old ones, but let's see the list in here. So we have the public, tenant, Technova 1 and 2, and these are the default or the Postgres schemas. So now if I approve this one, so we see that tenant approved successfully. And now if I refresh, I should see 6 schemas. So now I should see the tenant Alibu CMP. So now all I need to do is to connect with my new username, or the admin of the platform, so which is john.doe, and then I have password, and now I'm logged in as the new company. So if we check here, so here we have our dashboard. So like we have an inventory overview with a number of products, categories, stock movements, the low stock alerts, and also some movement trends, and the top categories, and also quick actions from here. So for example, I can create a product, manage categories, record movements, and add users. So if I go to products, so for now we don't have any products available, but first we need to create the category. Let's go here and say electronics, for example, and here let's say also electronics for the description. And now I will create a new product. Let's select electronics, and let's say MacBook, and here let's say maybe MacBook Pro as a reference. So here let's say maybe MacBook Pro, and the price, let's set it to 7,000, and the alert threshold, let's say 2. Let's create the new product, and we have the product just getting created. We can update it, we can delete it, we can do everything we need. So next we move to the stock movement. So we see how here we have our MacBook. So we can record our first movement or add the movement. So like both of them, they point to the same option. So here we can also drag and drop the pop-up in here. So let's add some quantity, let's say 10, and the nodes, let's say maybe import or purchase or whatever. Now, for example, in case I want to sell one laptop, so it will be of type out, let's say 1, and let's say maybe sale. And here we see it's of type out. And then we can also manage the users. So here we see all the users that belong to this company or to this tenant. So I will create a new one, and I will give him the role sales operator, for example. Let's call him, for example, Ahmed, just a simple name, and then ahmed@cmp.com. And let's give him a username. So let's give him just ahmed.cmp or sales.ahmed, for example, and a password. So let's create the user, and now we see that we have the user just getting created, and here all the information and the role. We can update the user, of course, and we can do everything we need. So now if I try to connect, let me copy the name from here or the username. So if I log out and connect using this new user, so the user can access the interface and he can see the list of products and categories, stock movements for that tenant. So no one can access the information or the data of another tenant. So he can see the list of more stock movements, the categories, he can create categories and so on and so forth. Of course, depends on the role and the permissions that user have. And of course, don't forget to hit the like button, subscribe if you're not yet subscribed, and of course, drop me a comment and tell me what you want to see next. Alright guys, so let's get started. First of all, let's understand what multi-tenancy architecture means. So in a single word or in a single sentence, a single application instance that serves multiple tenants. This means what? This means that I have tenant A, B, C, and so on and so forth. Each tenant has its own user or his own users. So tenant A, user 1, 2, 3, user 1, 2, and so on and so forth. All of them, they want to use our inventory management application. So when they send an HTTP or HTTPS request, so this will go to our SaaS application, a single instance, and then we have our backend, we have tenant resolver, we have the front end, and so on and so forth. So like all the classic flow. And then it goes to the data layer. So for the data layer, we have three options: single database, schema-per-tenant, database per tenant. So, but here, before diving too much, what do we mean by multi-tenancy? So imagine the application, so like this red box and this gray box. So this is our application. You can consider it as a building, all right? And this building contains so many apartments. And here each tenant needs his own apartment. So tenant A should not know or see what's inside the apartment of the tenant B. All right. So here we talk about isolation, data isolation, security, and so on and so forth. And this in the same way, tenant C should not see what inside tenant B and tenant A apartments. All right. Also, we need other levels of isolations, like mainly we talk about data isolation and of course security that comes with it. So this is the concept of multi-tenancy. So you build one application, but it can serve multiple tenants or multiple enterprises or companies at the same time. And the most important part is no company or no tenant has or should have access to the data of other tenants. All right. So like this is the concept. Now let's move on and I will show you what are the three types or like the three ways to implement multi-tenancy. And then we will move on to the code. So the first approach of multi-tenancy is called single shared database. This means what? This means all tenants share the same database and tables by and or using a discrimination by tenant ID. So this means what? This means we have our multiple tenants and we have all the multiple users. And here in our Spring Boot plus Angular application, so like the logic will be mainly in the backend. So like the front end will not hold the logic of the multi-tenancy. So we will have a filter, like a tenant filter, and of course a Hibernate filter. And then we will save the data into the database, but the discrimination will happen in here. So we will have a tenant ID column in each table. All right. So this column tenant ID will allow filtering data by tenant. So for example, if you want to fetch all the products of tenant A, all you need to do is to write the query select star from products where tenant ID equals tenant A or B or C and so on and so forth. All right. So like this is how it should be. And then let's talk quickly about the advantages and disadvantages of this approach. So the advantages, first we have minimal infrastructure cost. So because we have one single database, and then we have simple deployment and maintenance. Schema migration applied only once. If you need to update, upgrade, remove, or do anything in the database, it's only one single migration because you have only one database. All right, and it will be applied for all the tenants. Then we have easy cross-tenant reporting. So for example, if you want to count the products per tenant, or like who is the tenant who's using the application the most, simply you can like count and filter or group them by tenant ID. All right. Also, we have a simple horizontal scalability. So we can have multiple read replicas. So this will increase the scalability of the application. But now, of course, there are disadvantages. So the disadvantages, we have first the risk of data leak. So for example, if we miss a tenant ID filter in any query, we risk to leak all the information or the information of one tenant to another tenant. All right, but this is a risk. So this is something that you need to keep in mind. Also, we have weak isolation between tenants. Then we have performance impact. So one large tenant can slow down others. So this means what? This means, for example, let's say tenant A is heavily using the application and tenant B has only like few products, but tenant A has millions of products. So the tenant A will impact the performance for the tenant B, because when you filter the database, so here what you have, so you have millions of rows, but tenant B, he has only like few dozens or like few hundreds of data. So we have like a shared impact. All right. Also, we have limited schema customization by tenant. So we cannot, for example, if you want, for example, to have a feature for like a specific feature for tenant A, so we should apply all that, or like all those changes to the database, for example, or even the application. So the application, we can put that aside because just like logic and code. But the database, if for example we need to add columns for tenant A, remove other ones, and so because tenant A needs a specific feature, we need to apply that for all the tenants, and then this will complicate more the code because we need to check if the tenant is A, so we do this, otherwise we do that. All right, so then we have a problem for individual backup or restoring. So here we see that all the data are stored in the same table. All right, so we don't have like a separate table per tenant. But here, for example, if I want to export, like to back up the data or even restore it for tenant A, this will be really complicated or like even not possible. Of course, we can export it like in the CSV format or something like that, and then write a script to re-import it again and so, but this is really complicated and sometimes even not possible. All right. Also, we will have like larger indexes. So all data mixed together, because for example, we need to have an index on tenant ID plus the product name, or tenant ID plus the ID tenant. Like it's going to be always like the combination of tenant ID plus the index that we want. All right. So this complicates the indexing of our database. So this is the first approach. We will also implement this one. Now let's move on and check the second approach. All right, now let's talk about the approach number 2. So the approach number 2 is one schema per tenant. This means what? This means that we have a single database, but each tenant has its own schema or namespace with its own or his own tables. All right, so in the same way, so this level or like the upper level does not change because we have multi-tenants and we have our application Spring Boot plus Angular or any other application, because like this applies to any technology that you want to use. And here in the bottom side right here, we will use, for example, PostgreSQL, and we will create a single database, but inside this database, we will have multiple schemas. So as you can see here, for example, we have products, categories, stock movements, and so on and so forth. And we do not have the tenant ID column in each table. So we get rid of that, and instead we create a schema or like a specific schema for each tenant. So like schema alpha, beta, and gamma for the different tenants. All right. So here, like code wise or like the technical implementation, how this will be happened, or like, okay, so let's move on maybe from Spring, but let's explain it from SQL wise. All right. So for example, if you want, so you write a new SQL query and you want to select the products for the schema beta. So here you have two options. So whether you say, or like your type select star from schema beta dot products, or what you can do also, like there is a sentence or like a syntax, you can set the search path. So you can first execute a query called set search path equals schema beta, for example. And then every time you say you write select star from products, it will grab all the data from this schema. The next time when you change, for example, to schema gamma, then like when you set the search path again and you execute the same select star from products, it will fetch the data from the products table that exists or lives in the schema gamma. So this is how we do it generally. And then we will see how we will implement that, or how we can implement that in Spring, and how we can automatically, because this is the most important part, is how we can automatically determine or set the schema, because I don't want every time to write so many queries and complicate my code. So I want to write only like 1, 2, 3 classes, and then this should work out of the box. All right. In the same way, of course, for the approach number 1 we just saw. So we will explain all that when we come to the code. So here, let's talk now about the advantages and disadvantages. So the advantages, so we have better data isolation. So we have schema equals the schema is our logical boundary. So there is no mixing between, there is no data mixing between the different tenants. Also, we don't have a tenant ID colon, because this grants us a clearer business code. And then we have schema customization possible per tenant. So this is the example I just mentioned. So if I want to customize something for tenant alpha, I can do it only in the schema alpha. All right. So then we have per schema backup. So I can backup all the schema or all the database for a specific tenant. Like I don't need to write a script. I don't need to write like an export and import script. All I need to do is just to backup that specific schema. Also, we have a moderate cost. So single database instance, multiple schemas. So, okay, the number of schemas will increase, but we still always use one single database. And also there is a good balance between isolation and simplicity. So we have data isolated, and it's also simple to implement or simple to maintain from all the sides, like whether from the application or like code wise, and in the same way for when we talk about a database. Now let's see the disadvantages. So migrations must run on each schema. So this means what? Means, for example, I want to add a new column for products for all the tenants. So I need to run the same migration n times. Imagine we have like thousands or like 10,000 of tenants. So this means I need to run the same migration or the same SQL queries 10,000 times for each tenant schema or for each schema per tenant. All right. So like this is one of the disadvantages. Also, we have some limits on schemas or on the number of schemas. For example, like it really depends on the database management system. But for example, for PostgreSQL, it's around 10,000 schemas per database. All right. So, but to be honest, really, like this is a disadvantage. But if you have a SaaS application and customers or tenants are paying and you reach like 10,000 tenants, this means you have money, so you can scale. So no worries about that. All right. So, okay, it's a limit. I need to mention that because you should be aware of it. But to be honest, especially if you're having like a paid application, like or a SaaS with a subscription, this should not be a problem at all. So if you succeed to one day realize or implement your SaaS application, and if you use this video to follow or to implement, or if this video helped you, just give me a shout out. All right, next one. So we have also another problem, which is like cross-tenant reporting. So imagine, so this comes mainly to the not to the application, or like not the tenant level, but to the company level, to the SaaS application owner level. So for example, you want to run some statistics, reporting, and so cross-tenant. This is going to be a little bit complicated. So for example, you want to count the number of products for each tenant, compare them, have some graphs and so on and so forth to know like how the application is going and so on and so forth. This is a little bit complicated. All right. Also, there is a problem with connection pooling, which is more complex to configure, because like tenant A might have like thousands of users using the application at the same time. Tenant C might have only one, two, 3, or 4 users using the application at the same time. All right. And also we have shared resources. So shared resources, now we talk about a phenomenon called noisy neighbor. So the noisy neighbor effect, it's the same one that I explained before in the approach number 1. But for example, if the tenant A or tenant B is using the application or like consuming a lot of resources compared to the other tenants, so this will increase. For example, now we do not talk about performance or like the database itself, but we talk about the CPU and RAM. All right. And this will have, of course, impact on all the tenants. So this is the approach number 2. Let's move on and check the approach number 3, and then let's dive into the code and start implementing our SaaS application. All right, so now let's talk about the approach number 3, one database per tenant. So now, since you started understanding the different approaches, so now I can explain this like faster, I guess. So this means what? This means each tenant has its own dedicated database. So this is like maximum level of isolation. All right. So we have our tenants, we have our application, and then each application will communicate or like will serve, save, retrieve the data, and so on and so forth from a completely isolated database. So like this is a completely like a complete database in a different server, and so forth. All right. Or like it might be also like on the same physical server, but a complete isolated database instance. All right. Let's quickly talk about the advantages and disadvantages. So the advantages, it's really obvious and clear. So we have first maximum data isolation. Also, we have regulatory compliance. We will talk, for example, about the GDPR or sensitive data. Also, we have individual backup restore per tenant, isolated performance, no noisy neighbor effect, and full schema customization per tenant or per client. All right. But the disadvantage, it's really high infrastructure cost. So in databases equals n times the cost. All right. Or 10 multiplied by the cost of each database. Also, we have operational complexity maintaining, so we need to maintain n databases. Also, the migration should be applied n times. So there is a risk to drift between or like from one database to another. For example, if I apply the migration to the schema or like to the database alpha beta, but I forget to apply it for gamma, then we will face a drifting. All right. So also we have a cross-tenant reporting, which is very, very difficult because we can, but it's really difficult to join the data or the tables from different databases. All right. Also, there is a slow onboarding. So creating a database, provisioning the database, and so on and so forth. So like, for example, when a new tenant registers in the application and he wants to use our SaaS application, so this means that we need to provision everything. We need to create a database, we need to provision the data, we need to do multiple stuff, all right? Which is like, might take some time. Also, there is like a complex connection pooling per database, because here you need always to remember, so it's not only the database itself, but we talk about also the application. So like we need to create connection pools to each database. And this, like when we have multiple databases or like isolated databases, this might become a little bit complex. All right, so now we are done with this part. Let's move on to the next one. All right, so now let's have a quick comparison between the three approach. So I will try to go quickly through it because I don't want to waste the time, but please pause the video, read it carefully so you can grasp and understand the difference between the three approaches. All right. And by the way, these are the approaches that are used in real applications for even like huge companies. All right. So here, we have the criteria and we have the three approaches. So we talk mainly about data isolation, so you can see it also even from the number of stars. So data isolation for the approach 1, it's really weak. For 2, it's good. And for approach 3, it's maximum isolation. So infrastructure cost, Approach number 1, it's really low because we have one single database. For approach number 2, it's one single database, multiple schemas. So this also still low. And for the approach number 3, it's really high because we have n databases to maintain. All right, also like to provision and so on and so forth. So now we talk about the technical complexity. So for the approach number 1, it's simple. All we need to do is to use a filter and always add tenant ID equals the tenant ID that we will get or retrieve. For the approach number 2, it's a moderate because we need to route data sources between the different schemas to point each tenant to his own schema. For the approach number 3, it's a bit complex because we need dynamic data source plus pooling. All right, so like this is really like a bit complicated. Then scalability, like depending on the number of tenants. So if we want to scale up, the first approach is really excellent. The second one, it's good, but it's limited to the number of schemas that are supported by the database management system. For the approach number 3, it's limited because it only supports hundreds of tenants as max. Why? Because it really depends on, because like if you want to scale up, you need to scale the server, but you cannot install like thousands or like 10,000 or millions of database instances. So it's feasible, but there are some other approaches or some other ways to achieve this goal. So then the next criteria is schema migration. So the first approach is very simple. The second one is kind of complex. Like, let's say it's complex, not just kind of complex, but it's complex because we need to apply the same migration to n schemas. And then the approach number 3, it's very, very complex because we need to migrate all like different databases. So like one mistake can drift all the schema or all the tables in a single database, or in the same way here for the schema. All right. So for the performance, so for the approach number 1, we have the noisy neighbor effect. So we will have like really large tables, and some tenants, they might be impacted or affected by the other tenants. So for the approach number 2, it's a good trade-off because we have smaller tables per schema. But for the approach number 3, it's really excellent because you have dedicated resources for each tenant. So the next one, we have cross-tenant reporting. So like this is the cross-tenant reporting, or like this is the criteria. So for the first one, it's easy. Only select star without a filter. So then we get all the data. The second one, it's possible. We can use like union cross schema. And for the last one, or for the approach number 3, it's really difficult because we need to use distributed queries or ETL. Then, so we have like the backup or per tenant backup. So the first one, it's really not possible because like, as I mentioned, so it's possible, but in other ways, but not the database backup when we talk about database backup. All right. So for the approach number 2, it's possible. We can export or like we can back up a specific schema. And for the approach number 3, it's like totally easy because we can back up the whole database. Then there is like an important criteria, which is like the GDPR compliance. So because like it's about rights and security, data, and so on and so forth. So it's really difficult for the approach number 1 because we have mixed data. For the second, or for the approach number 2, it's acceptable because we have like different schemas, and all I need to do, for example, if I want to delete a schema, or for example, because here when we talk about the GDPR, let me just give you an example. So in case, for example, one tenant wants to cancel his subscription and then he asks for his data to be completely deleted. So for the approach number 1, you need to write custom queries, you need to delete all the data one by one, like you need to manage the relationships, what needs to be deleted first, and so on and so forth. For the second one, it's acceptable because all I need to do is to drop that schema and all the data will go with it. All right. For the last one, all I need to do is just to drop completely the database, or shut down the server, of course, and completely drop the database. So the last but not least, so for the use case, so here, for example, if you have like a SaaS or B2C or freemium, like large number of small clients, like the example of Slack, Trello, Notion. So like the first approach is really good for this kind of applications. So the second one, when we talk about SaaS, also like B2B or business to business, SMB, like this represents a good cost isolation trade-off. And like examples of companies using that, we talk about Freshdesk and Basecamp. And the last one, when we talk about SaaS enterprises, finance, banks, and so on and so forth, like it's like that really requires and imposes strong regulatory requirements like Salesforce or SAP. So like they use the approach number 3. So the last criteria is the implementation Spring Boot, like the Spring Boot implementation. But here, like this approach can be applied independently from the technology that you want to use. Like here, Spring provides provides things that we can use, provides like so many like tools and things ready to use. But for example, if you are using another framework, just search if you have that one, otherwise you can implement it. So like it should not be really complicated. So for the Spring Boot application, for the first approach, all we need to do is to use filter definition filter, and we need to use a Hibernate filter and use some of AOP, or like aspect oriented programming. All right. And also from Hibernate 6, there is like a new annotation called tenant ID, but I will not dive into this one because I want to show you a better approach, or like the approach that I want to show is how you can implement this yourself. Because if you simply use tenant ID and annotation and Spring does everything in the background, you will not learn anything. So like the purpose of this course is that you learn. All right. So the second one, we need like a data source or like routing data source. We need to set the schema or like the search path. And here we have like multi-tenant connection provider and so on and so forth. So like we will dive into the technical details. For the last one, so like we will implement the approach number 1 and approach number 2, but honestly for the approach number 3, like the video might last even like days to be finished, because like it's a little bit complicated. And we need so many things. Like for example, we need like abstract routing data source, we need data source map per tenant, we need dynamic data source creation, and so on and so forth. Like we need to manage pooling and so on and so forth. So like it's a bit complicated for a simple YouTube video or like for a simple course. And here, this is like just a recommendation, as I mentioned. So we'll implement approach 1 and 2 as they cover the majority of use cases and allow understanding of the fundamental mechanism of multi-tenancy with Spring Boot and Hibernate. So approach number 3 only theoretically presented for a complete overview. So like this is what I did. All right. So now we completed everything. So now we will move on and start implementing. So we will start by creating a Spring Boot project, and we will implement the approach number 1, which is like a single database and I will show you how we can isolate or like how we can fetch the data for each tenant. All right, so now I'm going to create a new Spring Boot project, and to be honest, like in this video, I already showed so many things like creating the project, setting up the dependencies, the properties, and so I will try to skip those parts. Otherwise, like I don't want to make the video too long. So I want to focus on the most important parts. So if you feel that something is missing, or like you are not understanding, for example, like some properties, why I pasted these properties and so on and so forth, you can like check any one of my previous videos and you will get everything in details. So here in my workspace or in my project, I will create a new project, and let's call it SaaS Multi-Tenant App, for example. So I will call it this way. I will use Maven type, or like project Maven type project. So it will be com.alibu, and here, for example, let's say maybe for the package, just SaaS if you want to. So here you can use any Java version, like starting from 17. Let's use maybe Java 21, 25. It doesn't matter, to be honest. So let's go to the dependencies. So first we need Spring Web. We need Lombok, of course. We need Spring Data JPA. So we need JPA. What do we need else? So, well, security, we will add that later on. We don't need it right now. So also we need the dev tools. So where is Spring Dev Tools? Yes, we need this one in here. We need Spring Validation. So let's add validation for data validation later on. And so let's check from here. if we miss, yeah, Spring Doc Open API, so this is good. So of course for SQL we need Postgres SQL driver, and the rest I guess this is fine, or like this, at least this should cover what you want to start with. If we miss something we will add it later on. And here just mention, like worth mentioning, that we'll be using the latest version of Spring, which is like Spring 4.6, and the other ones they're still in snapshot and release candidates. All right, so let's create the project. And now, all right, so this is our project. First, I will just start by setting up everything. So for example, I will start by placing or creating a Docker Compose file. So I will just copy paste it from an existing project. You can find all this in my different GitHub repos. So this is the Docker Compose. Like I will be using Postgres SQL with like 17.5. The container, I will call it SaaS DB, and the database name. So here I'm using environment variables. So if we have this one, or if we have the .env file, so it will be grabbed from there. Otherwise, we will use, for example, SaaS DB app as a database name. All right, so like this is like a classic Docker Compose configuration. As I mentioned, I already explained this like so many times. So honestly, I don't want to focus on this for the moment. And next, what I will do, I will add some properties. So I will rename this one. So I would like to use YAML representation. And here I will just paste the configuration and I will just walk through it. So here I want to use .env files or .properties to read these configurations, or like to read these environment variables, but I always have fallbacks. All right, so for example, the application, we will call it like SaaS app. And here for the database configuration, this is the URL. So Postgres SQL, so we have database host, otherwise it will fall back to localhost. And then the port, we will try to read it from the env file or from the properties file. Otherwise we fall back, or if this one is not available, we fall back to this one. So like this representation means that I want to read this one or this property from the env file or properties file. If does not exist, I will fall back to this one. So you can refer to all this at the same time. So here, yes, we forgot to add Flyway. We will come back to Flyway later on. So like it's not a problem. And then we will come back to this when we have, like when we will implement security. So as I mentioned, like I just copy pasted from another project. So now we have our project, I think, up and ready. Now we can move on to the implementation of our application. All right. So first I will rename this file. I'll just call it application, or SaaS application, as you want. So I will rename this one. And then the first thing we will start with is to create our base entity. So a base entity, as I explained before in multiple videos, it's just a mapped superclass where we put all the common attributes and fields in one class. So I will call it abstract entity. So I will create it in a common package, for example, and I will call it abstract entity. So this entity, simply I will add the Lombok annotations. So let me make this one full screen. So it will be a getter and setter and super builder. I will also use the all args constructor, no args constructor. So these are the Lombok entities. And here we need a mapped superclass annotation. All right. So then I will define few information. So first of all, I will have a private string ID. So this will be my ID, and I will say it will be a generated value. And I will use the strategy, not identity, but unique unified ID. And I can also add a static import for this one. And I can add the colon annotation. Let's call it simply ID. Nullable false and updatable false. So then what I will have few other information for auditing. For example, I will have, for example, like a local date time created at and a local date time updated at. So I will add the annotations for this one. So this one is created date, and then I will add the colon annotation. Let's call it created add. So this one is nullable false and updatable false. So I don't want to update this one. But in here, I will say it's last modified date. And also I will use the colon updated add nullable false, and I will say insertable false. I don't want to insert this one. All right. So here, this is our base entity. And if you want to, you can add, like, for example, like a deleted flag, just if you want to implement soft deletion and so on and so forth. So, okay, let's maybe add this one. So it's going to be a private Boolean deleted and a colon deleted, let's say nullable false. And in here, I will create a protected void. So I will create the void on create. All right. So on create, so I will make a check if this dot deleted is null. I will simply set it to false. All right. And in order for this method to be executed, I need to annotate it with a pre-persist. All right. So before persisting, before implementing or before executing the persist method, or like the save method, we will perform this check. We will execute this method and we will make sure that the deleted is not null. So we initialize it to false. All right. So these are the basic columns. And in here, what do I need? So I need, of course, a private string tenant ID. So let's give it a colon. Let's call it tenant ID and nullable false. All right. So this is our abstract entity. So then let's start with a simple entity. So I will create a package called entities, and here I will create category, for example. So this will be my category entity. So in the same way, I will copy the Lombok annotations, put them in here. And then this will be an entity. And then I will give it also the table with the name categories, for example. So here you see that it's complaining about that this entity does not have an ID attribute. But when I extend the abstract entity, so it will know that we have an ID defined in this abstract entity because it's a mapped superclass. And also for this last modified date and created date, we need to add an entity listener. All right, so entity listeners, and here we will use the auditing entity listener. And here, don't forget, when you use entity listeners, you need to enable something. You need to enable JPA auditing. All right, so here and on the application level, or you can create, for example, like a JPA configuration, and you put the annotation in there. So here I will just enable JPA auditing. All right, because if you do not enable JPA auditing, these fields will not be set automatically. All right, so for the category, let's define a private string name and a private string description. Let's give them colons. So let's call it name nullable false, and here let's give it a colon description. Description might be null. All right, so let me just go back here to my Docker Compose, and here for the database, let's call it maybe just simply SaaS DB, because like maybe it's multi-tenant or so, or like SaaS app. Let's simply call it SaaS DB. And in here, I will connect to my data source. So let me connect to the data source because we want to see that we are able to connect to our database, and we will need to create the database. So let's connect. You see connection succeeded. Okay. And in here, I will create a new database, and let's call it SaaS DB, for example. All right. So this is our SaaS DB. Let's open, let's select it from here. Let me refresh. Yes. So this is my SaaS DB, and also I can select the public schema. So now let me just make sure what is the DDL type we have in here. So DDL auto is none. So I will set it to update, for example. All right. So now we have the entity. All right. So now we have the entity. What we need to do, like the next, is completely classic. So before moving or like implementing the multi-tenancy, let me just prepare everything. So I will create an interface in repositories. Like I will create a package called repositories, and I will call this one category repository. So repository. All right, simply extends JPA repository for category and string. So let's import category, and that's it. So now we have our category repository. So then what do we need? We need a service, right? So let's create a new interface in services. So I will create a package called services, and then I will create a basic service first. So here I will have a basic service. So this basic service, it will be a generic interface. I will have an input and output. All right. So I will have void create, and we need the input as a request. So let's call it request, because we will use the request and response pattern. And here we will have a void update, for example. And here maybe we can also make this one final. And for the update, let's say final string ID, because we need the ID and we need the request itself. And then we have a find all. So for the find all, I will come back to it later on. We will implement it later. And I need the output for find by ID. All right. So like these are really, really classic. And finally, I need a void delete by ID. All right. So this is my basic service. So I will simply create a service for my category. So here I will create a class, an implementation package, and I will call it category service or category service implementation. So before that, so this is our basic service, but before that I need my category service, right? So I will create an interface, call it category service. And this category service will simply extend the basic or base service. So like you can call it whatever you want. So basic service, and in here I need to define my input and output. All right. So let's say category request and category response. So this will be my request and response. So let's create this class. So create class category request, and not in services, but I would like to create a package called requests. All right. And then let's create the response in the same way and in responses. So responses, and this is my two packages. So for the request, simply it will be something really or like pretty similar to the category entity. So I will copy the name and description, and I will put it in the category request. And in here, I can also use my Lombok annotations. I don't need super builder. I simply need the builder in here. Let's optimize the imports. And for the response, it will be also the same way. So for the response, and let's copy also these Lombok annotations. All right. So now I have almost everything that we need. So let's close these ones, and let's get back to the category service implementation. So the first thing, I will annotate this one with service, required args constructor, and SLF4J for logging. And then I need to implement my category service. So now I need to implement all the methods. And here you see automatically it will use category request, category response. All right. Why? Because here on the service level, we defined it as a service for category request or response. If you want to delegate that to the service or to the implementation, you can also use I and O or like input and output for the basic service. And here you have to define it. But honestly, simply just do it in the category service right here. All right. So let's inject our category repository. And of course, we will need a mapper. So let's say private final category mapper. So let's call it category mapper. So we don't have the class yet. So let's create it in mappers. And this one simply, it's a service or a component, like whatever you want. And in here, I will define a public, let's say category. So it should return a category object, and let's say to entity. All right, so auto completion works really fine. So here we have to entity, name, description, and if you want, you can also set deleted to false, but we already have it in the pre-construct or the pre-persist method. So the next one, I will have a public, another method just to transform the request or like from entity to request. And here simply I just need to return, not null, but category response. Here not request, but response. So let's use this one. Let's import it. So category response.builder.build. And here all we need to do is to define the information. So here I just need to add the private string ID. And here, let's say ID, it's entity.getID, and name is entity.getName. And finally, description is entity.getDescription. So this is our mapper. All right, so now let's move on to the category service. Let's start the implementation. So the implementation is quite simple. So what do we need to do here? So I will implement this one like once and for all. So the first thing, we need to check if category already exists. All right, so I will create a method. So check if category exists by name. And I need to pass request.getName. So let's create this method, and I will move it to the bottom in here. So let's paste this one here. So assuming that this check category exists, will throw an exception in case we don't have the category, or like in case the category already exists with that name, but we will implement this one in few moments. So let's say final category, and then we just need to call our mapper, and then this dot category repository dot save category, and that's it. All right. So this is the create method. So now let's just quickly implement the check if category exists. So I will have a final optional of type category. So I need to use the entity. Let's import the optional class, and let's say category equals this dot category repository dot find by name. All right, and we need to pass the name as parameter, and that's it. So here, let's say maybe find by name, ignore case. We want to ignore the case, like just fetch or find all the categories no matter what the name, like uppercase or lowercase. And here all I need to do is just to declare my method. All right. So here simply if the category is present, simply I need just to raise a runtime exception or a duplicate exception or whatever. So I'll just add a log.debug. So I don't want it to be an error, but simply a debug log. And here, let's say, for example, I want to return a custom exception. All right. So I can create, or like we can create custom exceptions, but we will do that later on. All right. So like we will come back and do that in a few moments. So because I just want to focus on the multi-tenancy in this video. So here we have the create. So now let's move on and implement the update quickly. And in here, first what we need to do, check in the same way if category already exists by name. So like we need to do the same check. All right. So, and before that, we need to make sure that the category exists. All right. Before checking the name, we need to make sure that the category exists. So here, let's say, for example, final optional of category, let's say, or let's call it existing category. So let's find it by ID. And here, if my existing category dot is empty, so let's debug category not found, and let's raise a not found exception or runtime exception, or if you want to, an entity not found exception. All right. So like this is the JPA or like the Hibernate exception. So then we need to make sure that the same category does not exist by name. All right. So wait, I think maybe this does not make sense, because we can update the same category with the same name. Or we can do the following. So here, if the request, so here let me do this. So final category, existing category dot get. So if my category dot get name equals ignore case to this one, so if they are equals, so I don't need to do anything. But if not, if they are not equal, so this means I want to rename my category. This means I need to check if the category exists or not. All right. So here just simply if not. So otherwise, if the new name, so if the new name is different from the existing name, I need to check, right? If not, I will not do, or I don't need to perform any check. So let's say final category to update. Let's do a mapping. And here, so let's say category.set ID, and then this.category repository.save. As simple as that. All right, let's format the code and let's optimize the imports just in case. So then we have the find by ID. So this one is quite simple. So simply I need to return this.repository.find by ID, and then I need to pass the ID as a parameter, then map, so this.mapper, and then to request, to response, I need to rename this one. So let's rename it to response, and then or else throw, as simple as that, or else throw entity not found exception. So then finally, finally the delete method. So here final category, first I need to check if the category exists or not. So final category, let's say category equals this dot category repository dot find by ID. I need to pass the ID, and then or else throw an exception. Otherwise, simply this dot category repository dot delete, or you can implement soft deletion. All right, so you can just simply set it to delete it true, and then just save the entity. But here let's do some physical deletion. All right. Okay, so this is our service. Now we can start our application, and let me show you or explain to you the issue or the problem with this. So this means that when we run the application and we try to save or create categories for multiple tenants, this means that every tenant should see only his own categories, not all the categories or the categories from other tenants. So let's move on and try this out. Yeah, before moving forward, before starting and testing the application, let's create the controller. So controllers, and then let's call it category controller. All right, so for the category controller, it's going to be something so simple. So here we will have our REST controller annotation, request mapping, let's call it /API/v1/categories, and required args constructor. So required args constructor, and if you want to SLF4J if you need to add logs. So let's first inject private final category service. So category service, or let's simply call it service as a short name. So here I need a public response entity, and let's say of type void, and here let's say create category. All right, so here let's say at valid, so we want it to be valid, and request body, so make sure that you import it from the correct one, and final, well, not string but category request, and then simply all I need to do is to call my service.create, so this .service.create, and then just return an OK. All right, so and then we need, of course, the post mapping annotation, just without anything, just a post mapping annotation. Next, let's implement our put mapping. So the put mapping, it will be slash, well, not slash ID. I prefer using category ID. And here it's going to be a path variable with the name category ID. Let's check in here and then finally return response entity dot OK. So category dash ID. And now, yes, everything is fine. So the next method is find by ID. So it's going to be a get mapping and slash category ID, and this should return a response entity of type category response, path variable category ID, and everything is fine. So I don't want the get all, we will implement it later on. So here I need a delete mapping. So in the same way, category ID, so path variable, delete, and then return this. Like return just response entity dot OK or accepted or no content. So for example here, maybe let's say no content dot build. All right. So and now I guess everything is fine with the controller. So we have the controller, and also like with the help of the auto completion of IntelliJ, everything was implemented super fast. All right. So now we can start our application and test. So like just to explain to you the scenario and the issue, and then I will show you how to fix that. All right, so let's go ahead, start the application, make sure that the database is created and the tables, and then we will move to Postman just to try out this application. So now the application is up and running. So what we can do, we can check our database and make sure that the table was created. All right, so let me, yes, I think I know why. So here, where is it? Yeah, it's not SaaS app, we just renamed the database. So let's restart. And then let's check the database. And here, if I refresh, I see that I have the categories table, and for now it is empty. All right, so let's go to Postman or open Swagger UI, and from there we can test. But let's do that on Postman. So here, as you can see, I already prepared the request on Postman. So we will just hit /API/v1/categories, and it's a post request, and we want to create our first category. Let's click on send and check what will happen. So we have 500. Let's check what is the problem in here. Maybe we forgot something. Yes, yeah, because the tenant ID violates. All right, so I will show you how to quickly fix that, and then of course we will implement this. So here, just an extra check. So if this .tenant ID is null, let's say just tenant ID equals default. Like we don't care about that for now. All right. Because then we need to automatically set the tenant ID and automatically inject it when we fetch the data. All right, so let's go back and let's try clicking on send again. So there is something. So the updated art, I think the updated art, I said, yes, that's a problem. I will quickly remove or delete this table. So let's drop this one and restart the application to create the table, because the updated art should be or might be nullable, right? So now I'm pretty confident that this will work. So we have 200, and if I open my categories, let me refresh, tables, categories. Now we have the category. Let's say, for example, I want to create category 1, but for gamma, all right? And then let's say category 1 for beta, and saved. So now, for example, if I copy this one, create a new request, and it will be a get method or even a get by ID. So we did not implement the get, but we can quickly implement it. So this should return. So yeah, it's not supported. All right, so I was feeling a bit lazy, but let's do that quickly. So what I will do, I will go to category service implementation, category service, and in my base service, what I will do, I will add a find all method. All right, so it will be a list of category or a list of output and then find all. All right, so now we need to go back to the service implementation and we need to implement this method. Let's quickly implement it, find all. So this should return this dot repository dot find all, just find all, and then stream and then map, not all match, just I want to map, and this dot mapper, and then to response, and then to list, and that's it. Now I just need to go to the controller and add a new get mapping endpoint, get all categories. So it's not an iterable, but it should be a list of category response, and that's it. So let me restart the application. So we will not lose the data because I have the update DDL. So now if I click on send, so this returns all the categories from all the tenants. So one way to say or to filter tenants, what we can do, we can set a header, right? So here we can add a header when we try to get the category and also when we try to create a category. Let's say, for example, tenant, or let's call it X tenant ID, for example. And here let's say alpha. Normally, if I pass this header, I should only select the alpha or the categories that belong to this alpha tenant. But for now, this does not work. So now let's first understand how the request flow works when we will implement filters, or when we will filter data for each tenant. So now we just tested that the application, or at least this basic API, is working fine. Like the category we can save, we can update, and we can do whatever. So then what we want to do, or what we need to do, is we want to implement this multi-tenancy for the approach number one. So let's go ahead and implement that. All right, so now this is the flow, or the HTTP request flow for the multi-tenant architecture. All right, so the flow is the same or almost the same for the approach number one and the approach number two, and even the approach number three. So like this is a classic or a standard HTTP request flow. Like you need only to add or like do some changes and adjustments depending on the architecture or the approach that you want to implement. So in here we have 6 steps. All right, in order to achieve or like filter out our data per tenant. So everything starts from an HTTP request, whether an Angular client or Postman or Swagger or any type of client. So we will send a request like get request or put request, and then we will send or we will pass an X tenant ID header. All right, or even an authorization. So the authorization, this will come later when we implement the approach number 2 with the security and all this stuff. So here we have the X tenant ID as a header. So let's say it's alpha. So the X tenant ID header identifies the tenant. So then we move to the second step. So the second step is the following. So here we will have, or we need to implement a tenant filter. All right, so this tenant filter, what it should do, so here we need to extract the tenant from the header. So simply request.getHeader X tenant ID. We need to store that in a thread local. So we need to create a class or a service, or like it is simply a class. Honestly, it's not a service. Like it's not a Spring service, but it's a class where we can set the current tenant, where we can save the current tenant. And then we need to continue the filter chain. So like this is the filter. So this is how the filter looks like. And finally, once the request is over, we need to clear the context. All right, so like this cleanup is mandatory. So here when we call this set current tenant, so this is what will happen. So on the right hand side, so we have our thread local. So it's our tenant context class. So this, for example, will create a thread with the ID thread 42, and the value of the tenant equals alpha. So the same thread local is read by the aspect at step number 4. So we will see, or we will check that in few moments. So what is the life cycle of this thread? So first we set alpha. So it's available throughout the entire request. So like all the, like throughout the entire request, this alpha or the value of the tenant is available. So every time we call the get, this should return the alpha. And finally, as mentioned in here, we need to clear. So after the request is over and we send back the response, we need to clear the context. So in this case, we know, or like we will not mix the tenants per request. All right. And the fifth step of the life cycle. So the thread recycled for the next request. So now when we move on to the third part, so we will come, so after the filter, we will hit the controller, product or category controller, for example. So we have a get mapping, find all. So here, no multi-tenant code here. So as you can see in the find all method, we don't want to pass each time the header, or we don't want to grab the tenant ID from the header and every time add like a workload to all our requests where tenant ID equals this and that. So we can use a smarter way. So the smarter way is the following. Here we have our, for example, on the level of our product or category service plus the tenant Hibernate filter. So the tenant Hibernate filter, it's going to be an aspect or AOP, aspect or oriented programming. So when we call product service dot product repository dot find all, so on the product service level, because this is where the transaction or the Hibernate transaction starts. So this should trigger the tenant Hibernate filter, the aspect that we will define in the tenant Hibernate filter. So this means what? So we want to have an execution on any service, and then we want to enable the filter called tenant filter. So what is this filter? We will see it in a few moments. And then this aspect, it will read the thread local and to get the current context. So this should return alpha. And then Hibernate or the ORM inside it, what it will do? It will do automatically or an automatic SQL generation or an SQL injection. So I'm not talking about the security SQL injection, but it will insert a part of the query. So this means what? Since we will have our filter already defined, so this is the base query. Select star from products or categories, and then plus automatically added filter. So the filter will be added from here, all right? Because we will trigger or enable the filter. So Hibernate will add this one. It will automatically add where tenant ID equals alpha. So the final SQL query that will be executed, it will be select star from products where tenant ID equals alpha. And then when it comes to the database with the single shared database, so what we have, so we have, for example, 2 lines for the tenant alpha, and this will only return the rows 1 and 2 for the tenant alpha, and the gamma and the beta, for example. So like these 2 lines are completely invisible. And this is like just a structure or like how the JSON will look like. All right. So we have all this to implement. So let's go ahead and implement it. So let's start with the filter, and then we will implement the aspect, and finally we will test it. All right. So the first thing we need to do is we need to adjust our abstract entity. So it's not like a complete adjustment, but we need to add a few things. So here we mentioned that we want to have filters. So the filter should automatically inject or add the workloads called tenant ID equals our tenant ID. All right. So here we need to define at first a filter definition. All right. You can define multiple definitions. All right. So let's give it a name. So the name here is really important. So let's call it tenant filter, for example. So you need to remember this name. Okay. And then we have a list, or we can pass a list of parameters. And here we only have one parameter, param definition. So here the param definition, let's give it a name. Sorry, it's an annotation. It's at param diff. And let's give it the name. Let's call it, for example, tenant ID. And here we need to provide the type. So the type is simply a string, right? So it will be a string.class. So after the parameters, we need to define the condition. Like when we want to trigger this filter. So here, let's say default condition is our tenant ID equals tenant ID. So this is the parameter and this is the field. And here you need to make sure that you are using the correct column name. All right, so this is very important. So once you define your filter, then you need to declare it. So we have a filter, right? So let's give it a name, and here let's say our tenant filter. So this is the definition of our filter. So here we have, or we defined the filter. Let me first just make sure that I imported the correct one. So yeah, so all of them, like the filter definition, the filter param, the filter, all of them are from Hibernate, like org.hibernate.annotation. It's not a Spring annotation, right? So here we have the filter and the filter definition. Now the next step is to enable this filter. But before enabling that, we need first to fetch the tenant ID from the header from each request and store it in the context. So the next step, let's go ahead and implement the filter of the tenant context. So the tenant context is something honestly super easy. So it's not really complicated. So I will go in here and let's create a new package. Let's call it config, and I will call this one tenant context. So let me rename it. So it's tenant context. Let me make this full screen. So this tenant context, simply it will contain a private static final thread local. Let's call it, so here I will just rename this one and I'm gonna call it current tenant. All right. So equals new thread local. So here I will simply have a public static string get tenant and a public static void set current tenant. So I will just move this one to the top and this one to the bottom. So let me format the code. And finally, I want to have a public static void clear. And all I need, so let me explain something. The thread local, you only have like three methods, like you have get, set, and remove. All right. So here is to set a value, to get the current value, and to clear or remove the value. All right. So like this is our tenant context. Like it's as simple as that. So this thread local will ensure what I already explained before. All right. So then what do we need? We need to implement our tenant filter. So the tenant filter is the one that will fetch or that will retrieve the header called xTenantID, for example, from each request. So let's go ahead and do that. So in the same way in the config, I will create a new class and I will call it tenant filter. All right. So you can also like create a once per request filter and so on and so forth. So like any option works. So here I need to implement filter. So, and the filter, it's from jakarta.servlet. All right. So it's like you should not mix. I need to implement the doFilter method. And inside this doFilter method, this is where all the magic should happen. So I will annotate this one with a component. And let's give it an order. So the order, let's use the ordered dot. So from the Spring Core and highest precedence. So the highest precedence is the mean value. So like it's the other way around. So like the lower the value, the higher the order, right? So now what do I need? First, I will, since I know which header I want to use, so I will create a private static final string. Let's call it tenant header instead of tenant ID. So this one I will call it xTenantID, and I will make this one as an uppercase. So this is our tenant header we want, the one that we want to extract. So from here, what I want to do, first I want to cast my servlet request and servlet response to both HTTP servlet request and HTTP servlet response. All right. So an HTTP servlet request, because like from there, it's easier to grab the data and to fetch the headers. All right. So let's call this one request equals HTTP servlet request, not response. So here request, and I will cast my servlet request, as simple as that. So let's do the same, final HTTP servlet response, and I will cast this one. All right. So here this one is request. And why IntelliJ is doing this to me? All right. So we have request and response. So then I will have a final string tenant ID. Simply I can just do request.getHeader, but instead of that, I will create a method called resolve header. Just I will show you what this will do. All right, so I will cut this one and I will create a method called resolve header. And this resolve header, it should take the request as not the response, but the request as a parameter. So let me implement this one. So the first step is to get, so final string, let's call it tenant ID. So tenant ID equals this one. So I try to get the header, and then I need just to simply do some check. If my tenant ID is not null and my tenant ID is not blank, and not tenant ID is not blank, simply I want to return the tenant ID dot to lowercase. So tenant ID dot to lowercase, otherwise I will return null. Okay, so this is my resolve tenant. So here I need to make a check. So if my tenant ID is null or my tenant ID is blank, so you can also use like the isBlank method from string utils from the Spring framework. So here what I want to do, I want to do response dot set status, so it will be a bad request. So also I can do response dot set content type application dot JSON, and here I can write an error into my response. So response dot get writer, and then dot write. So here I want to write the following error. So here maybe let's say error tenant ID is required, or maybe let's say tenant ID is missing. Tenant ID is missing in the request header. So here please add the header x tenant ID, and that's it. All right, and then of course don't forget to add the return, so we can exit the method. And then I will add a try and finally block. So here finally, and here in this finally, simply I need to call the tenant context, not set current tenant. Why all this suggestion? But clear. I want to clear the context. So this is what we explained already in the diagram before. So here simply what I need to do is my tenant context.set current tenant, and of course don't forget to pass the filter chain. All right, like to execute the next filter. So this is our tenant filter. What it does, simply it extracts the tenant ID from the header called x tenant ID. If we cannot find the header, we simply return an error and a bad request saying that the tenant ID is missing. All right. So if we start the application even at this level, and we try to fetch the data, maybe we can do it. And we try to fetch the data without passing the tenant ID, we should get a 400 or like 400 response saying that the tenant ID does not exist. So here I do not pass the tenant, and if so it should be in here. I will remove this one, and now I should get a response. The tenant ID is missing in the request. Please add the header x tenant ID. All right, but if I add this one, so the response or like the query will be executed, but for now we did not yet implemented or like enabled the filter that we created to filter out the tenants. All right, so let's go back in here and continue implementing this one. Just one thing I would like to update quickly in here. So we have tenant ID. So this one I will call it, I think I have the names. Yes. So let's call it this one alpha, and this one gamma, and this one beta. All right. So this way, I'm pretty sure like when I set my tenant ID, I should not get mixed data. All right. So after implementing our tenant filter, what we need to do is now we need to implement our tenant Hibernate filter. So this is the one that will enable automatically our filter, the one that we declared in here. So here we declared the filter. So this is the definition, what we want to do like inside this filter kind of, and this is the filter itself. All right. So we want to enable this filter at each request. So how to do that? I will create a new class. So here, let's call it tenant Hibernate filter. All right. So this tenant filter, you might also call it like tenant HTTP request or tenant HTTP filter if you want to, but this is the Hibernate filter. So this Hibernate filter, first it should be a component, and here I will add the aspect annotation. So this will be an aspect. So here I will have a private entity manager. So my entity manager, let's call it entity manager. And this, I need to add the persistence context. All right, like to inject my persistence context. So now all I need to do is to create a method. So the method should be public and of type void. All right. So let's call it activate filter. So activate filter, and it does not take any parameters. And we will see what we will do within that. So before adding any annotations, let's implement this one. So I will have a final string tenant ID. So I try to get the tenant from the context if it is available. So then if my tenant ID is not null, what do I need to do? I need to get the session, like the Hibernate session. All right. So it will be a final session. So final session, the Hibernate session equals entity manager dot unwrap session dot class. So this means that I will get my current session. So here activate the filter to inject the tenant ID. So simply, well, it's not this one. Yes, so session ID, not session ID, but session.enable filter. So this should be the filter name, the one as we have in the abstract entity. So I will just copy paste it to avoid typos. So I don't want to debug later on only for typo. And then I will say set parameter. So the parameter is my tenant ID because the parameter is this one. So if you call this one X, you set it here to X, right? So this is something that you need to pay attention to. So set parameter tenant ID. So it's not enough only to enable the filter. So in this case, you can just simply enable the filter if you have, for example, so if you have the condition like where deleted equals false. All right. So you only need to enable the filter. But if you have a parameter, you need to set it in here. So in this case, or in this way, where every time we receive a request, we will do all the flow like extracting the tenant ID from the request, save it in the tenant context, and then this aspect should be executed. But the question is when. So I want to execute this before what? So this is an auto completion, but we will fix it. So before anything in my com.alibu.sas, but not in repositories, but I want it to be in services. All right. So in services.star. So any class inside services, or you can even be precise. All right. So you can even be more precise, saying like inside services dot implementation, for example, and anything that starts and ends with service, for example. All right. Or like service implementation or whatever. All right. So let's continue explaining what happens. So here, this like any execution for this package or for this specific package or path for any class inside this package or inside this full package or path, and here or on any method with any parameters. All right. So like this is the explanation of this one. Let me explain it once again. So I want to execute it on any request, like this is how to say it. And then on this package, any class inside this package, any method inside that class with any parameters. All right. I want to execute this method, right? So now if I simply run my application right now, if everything is fine and I did not forget anything. So now when I try to fetch the data for this alpha, I should only see this line, like the other two should be ignored. All right, let's try it out. All right, so it's not working. So let's check. Maybe let's first check the database. Let's check the tenant ID in the database. Maybe yes, so gamma, beta, and alpha. All right. Or maybe the filter was not set or was not activated. So let me remove the implementation. I will just add it to any services. Let's restart and let's see what happens. Or maybe this filter is not triggered. All right, so we will debug. We will debug just in case. All right, so let's try to send again, and in here maybe the header is wrong. I would just copy the header once again, but no, it should not be the header. So what we can do in this Hibernate filter, I will set a breakpoint in here, send again. So like this is an occasion to debug. So the tenant ID equals alpha. All right, so then let's go. All right, okay. Yeah, there is one thing which is really important. It just came back to my mind. So what is happening exactly in here? So let me explain this first. So here we are injecting our entity manager and we are trying to get the session. All right. So when we get the session, so this means that we want to get the session from a specific transaction. All right. So this means that our service or any service that I want to apply the aspect to needs to be transactional, or at least the method should be transactional. All right. So now I need to use the transactional annotation. If I do, so here I can just hot swipe the code or reload the code. But if my class or the method that I want to inject my tenant ID is not transactional, so this means that the tenant ID will not be injected, because here we are getting the session from the entity manager and the session is inside the transaction, right? And also there is something very important. So we can also try it out. So if we switch this one to repositories, we will do it later. And I will explain to you what's the problem. Maybe some like one of you wants to use it on the repositories level instead of the service. So let's go back to Postman in here. And now if I send again, you see that I only retrieve the alpha data. So here, for example, if I change this one to gamma and send, so we see the category for gamma. So if I send, for example, something that does not exist, it should return an empty list. So in this way, we are correctly isolating the data from one tenant to another. So even if someone tries to inject any tenant ID or like any tenant ID to try to retrieve the data, this will not work. And also, like later on in this video, we will implement security and we will secure the data more and more. All right. All right, so this is the first approach. And as we can see, the approach number one is completely or like working completely fine. What we will do next, we will implement the approach number two. So the approach number two is to have a tenant schema per tenant, or like a schema per tenant. And this should happen in an automatic way. So I should not manually provision my my schema. So the schema should be created automatically. And of course, we need to create the tables and maybe inject anything we want. So let's go ahead and implement this. All right, so first let's have a look on the data model that we have. So here we simply have, or we will have 3 tables. So we will have products, categories, and stock movements. So here you still see the tenant ID because this belongs to the approach number 1, which I already implemented, and I will show you the code. So like the code is completely classic, and I showed that hundreds of times in my different videos. So let's go ahead and check the data model. So here we have products and we have categories, and the relationship is 1 to n because one category has multiple products. The same, each product has different stock movements, like they can be of type in or out. All right, so like in is plus, out is a negative, and it's a 1 to n relationship. So one product has multiple movements. And here, as you can see the legend, so this is the tenant ID. Here is a foreign key because in the product we need to have the category ID, and the stock movement we need to have also the product ID. And we can also create some indexes to improve our like the performance of our database. Also, we have a movement type, which is like in like goods received, customer return, and so on and so forth. Out is a sale, transfer, loss, adjustment, and so forth. So like this is what in or out and out means. So this is our data model. Let's have a look on our class diagram model for these entities. Like what are the entities that we need to create? All right, so this is our class diagram. So here we have our abstract auditing entity or our abstract entity, and all the other classes or entities, they inherit or extend that abstract entity. So we have category, stock movement, product, and so forth. So with stock movement, we have the type or the movement type, which is of type movement, which is an enum, right? So here, this is our class diagram. So like it's honestly simple. And here we have the filter definition and the filter, which we will remove because we will start implementing the second approach. But I would like to show you the full implementation of the first approach first. All right, or like the approach number 1 first. All right, so this is the class diagram. As I said, it's classic, nothing really fancy and nothing really like missed that I need to mention. The only thing in here is just like this filter definition and filter, I moved them to the abstract entity, so we do not need to repeat them each time. All right, so let's move on and let me show you the implementation for that. All right, so also for the implementation, there is nothing really fancy. I just want to show you what I added. So here I first created an object I called page response because I want the find all method. I want it to be paged response. All right, so I don't want to return everything, but I want it to be paged. So I created an object called page response, and it's a generic type. All right, so it contains a list of the type that we should pass. Content, it has a page size, total elements, total pages, has next, has previous, is first, or and is last. And also I created a method called of. So we pass an object of type page. So this page is from the Spring Framework data domain page. So like it's like a pageable response, and then simply we build page response content. We set the content, the page, the size, and so on and so forth. So like it's really a classic object. So like as I mentioned, nothing really fancy in here. So here we still have our tenant context filter and Hibernate filter. And in the entities, I created the required entities. So we have the category, we have the product. So this is our product table. So we have the name, reference, description, alert threshold, price, category, and a list of stock movements. All right. So the same for the stock movements. I simply called it stock MVT. And for the table, I called it stock MVTs, like for stock movements. So we have a type, which is an enum. It's an in or out. And of course, we need to add the enumerated annotation, and we have a quantity, the date of the movement, we have a comment if you want to, and here this is the relationship with our product and with the product ID as a foreign key. So then what do we have? Also, I created the different mappers. So like these are simply classic mappers like to entity to response and so forth. So the same for the repository. So we have the product. So for the product, I added a method called find by reference ignore case, because in the product here, so we have a reference. So this is the logical identifier of a product. So it's nullable false and unique true. All right. So this is the method that we need in here. And for the stock movement, it's also like a classic repository, just an interface that extends JPA repository. So next, what do we have? We have the requests and the responses. So product request, request and stock movement request, product response and stock movement response. So we will add the IDs later on because I forgot to add them. So what do we have next? So we have the list of the services. I made a first update to our basic service for the find all method. It no longer returns a list of our response or of the output, but it returns a page response. All right. And now in the implementation, I will show you how we do that. So for the category, like it's also like a classic or a simple service. For the products, the same. And for the stock movements, it's also the same. All right. So then for the implementation, so let's start with the category service. And this is the only change that I made is for this find all method. So the find all, it should receive a page and size parameters. And then all I need to do is to create a page request object. So it's a page request dot of page and size. And then I create a page. So when we execute or when we call the find all method, we have like two implementations. So we have a find all without parameters and we have a find all with the pageable. So this is the page request because we want to paginate our responses to improve the performance of our application. And then all I need to do is to map these categories. So this page of categories, we have a method called map. So like it's predefined method. And all we need to do is to pass a mapper method. So our mapper method is this category mapper dot to response. And simply we return our page response dot of. So the method dot of is the one I showed few moments ago. And for the product service implementation and stock movement implementation, it's the same implementation. So for the create, for example, we check if the product already exists. So check if product already exists by reference. So it's the same implementation. And then check if category exists. So we need to check if the category that we want to assign to our product already exists. If it's the case, we simply need to set the information or like to map and save the entity. So the same for the update. And also we have the find all, which is also the same. Find by ID, delete, and so on and so forth. So like you will find all the code available in the GitHub repo. And also like I had I have like different commits at each stage. So you can go back to each stage to check the code. All right, so then finally we have the stock movement service implementation. We have the create, update, find all, and so forth. So this is the basic implementation. So there is something else. So here in the pom.xml, what I did, I added the Flyway migration. All right, so like the Flyway migration dependency. So it's simply this way. So it's the dependency, or you can also like click here and add starter and search for Flyway. All right. So then when you add Flyway, in case you add it manually, there is something you need to take care of. So when you add it the second time, or like when you add it from here, it might only add this dependency, right? Which is like the Spring Boot starter Flyway, sorry. But for each database, you need to add this specific dependency. So for example, for PostgreSQL, you need to add Flyway database PostgreSQL or PostgreSQL. All right. Otherwise, you might face issues when you start up the application. When you add Flyway migration or Flyway dependency after creating the project, make sure that you create this folder under the resources. So the folder, you need to create a first one called DB, and inside this DB you need to create another folder called migration, and inside it you can create any other subfolders, but the most important is db.migration, because Flyway, it will try by default to fetch or to read all the SQL migration or the SQL scripts from db.migration or db/migration folder. The other change I made, so here I have like a v1 init database, so like it's simply like an SQL script to create the categories, products, and stock movements table, right? So this is all I did. And in here, so let me close all this. So here in the application.yaml, I mentioned like in the beginning that we have our Flyway configuration. So Flyway enabled by default, like enabled true, baseline migration true, and here we have the location. So the location here, it's, so you can ignore it if you have everything directly under db.migration. So you don't need to put this one or to add this property. But if you have other subfolders, or if you want like different organization, also like the one that we will do later for the multi-tenancy, like for the tenant per schema-per-tenant approach. So here you need to add also the other path where to read that from, or like where to read these SQL scripts from. So the schema is public, the table, so like this is the table that Flyway will create. We will call it Flyway schema history, and validate on migrate, we will set it to true. So here we can keep the DDL auto to update, or you can set it to none but not validate. So validate may be at this phase, but when we move on to the next one, validate will no longer be the best choice. So we will set it to none. All right. So now also I created something else. So here, as you can see, I'm trying to read this information from an env file, and here we added the configuration. All right, so we added spring config.import. So it's optional. Optional means if the file does not exist, this will not raise an error, or this will not stop the application from starting up. And then we want to import a file, and the file, it might be a .env or a .properties file. Right, so this is the configuration, and here for this .env.example, so this is the one that you can push to your GitHub repo, but you never push the .env file. So all you need to do, just duplicate this file and remove the .example, and here replace with your values. All right. So these are the information that I have, like Spring profiles, DB host, port, name, and so on and so forth. So like all what you define in here, you can simply put it in your .env for like to start your application locally, but also add the reference to the .env.example. So if someone else wants to use or clone the repo, they simply can find it, or like they know what are the properties that they need to set. All right. And here, this is our Docker Compose. I did not make any changes there. And this is simply, so now all I need to do, just to make sure that my changes and that the code that I wrote is working fine, I just need to run the application. So here I completely deleted the database and the categories table that I created earlier. So now I will start the application, and let's see if everything is working fine. So here, as you can see, so now alter table, add tenant ID, and so forth. So here, this is the migration. So now if I refresh, I should see 4 tables. So like categories, products, and stock movements, and of course our Flyway schema history. So the Flyway schema history, it keeps track of the different files or SQL scripts that were executed by Flyway. So here categories, we have the categories table, the same for the product, stock movements, and so forth. All right. So at this level, we have already the first approach totally implemented for our application. All right. So like our application now is completely functional using the first approach. So like retrieving the tenant ID and enabling the filter to set the tenant ID and filter out all the data. But now I would like to move to the next part, which is, in my opinion, the most important, and this is my goal for this video, is to show you how to create or how to implement the second approach, which is a schema-per-tenant. And the most important part of that is I want to show you how you can automatically create the schema, automatically provision all the data and tables for each tenant, and of course, like how we can add the Hibernate filters, the routers, and so on and so forth. All right, so let's move on and start implementing this. All right, so now in order to start implementing the second approach, so we mentioned or we explained before that we have a tenant and each tenant has users, and then for each tenant we have the categories, products, and stock movements for each of them. So here we can identify that we have a common part, which is users and tenants. All right, and we have a special or an isolated part or isolated tables, which are the tables that we already created in here. All right, so like we will start now implementing our multi-tenancy step by step. So the first thing I want to do is to create the different entities, which is we need an extra entity for the tenants and another extra entity for the users. All right, so first I will go to entities in here, open my abstract entity, and I will add two columns for the auditing. So the created by and the updated by. So before deleted and after updated at, I will add these two attributes, the created by and the updated by. So the created by is updatable false and nullable false, and the updated by is insertable false, and it might be null as well. All right, so then I will create my user entity. But before that, I would like to clean up my abstract entity. So I no longer need this filter and this filter definition. So I will remove both of them. And also here in the config, I have my tenant filter and tenant Hibernate filter. So I can remove them, but I will simply comment out these annotations, and in the same way in here. So they will no longer be executed. All right, or we can completely remove them. So we will do a cleanup later on. All right, so now let me first create, and of course, before that, in the abstract entity, we no longer need this tenant ID. All right, so we don't need the tenant ID attribute, and also we need to remove or delete that from here, and that's it. So now let's first create the user, or even we can start with the tenant. All right, so in the entities, so I will create a tenant entity, and this one, like it's a really simple one, so I will just even copy paste the annotations first. So let me put this one here, and of course extends abstract entity, and then I will add a few attributes. So I will just fast forward this, and then I will explain the different attributes. All right, so this is our tenant entity. So the tenant entity, what do we have? So a tenant is a company, right? So like this is what we mean by a tenant. So we have a company name, company code, we have the email, like the company email if you want to, and we have a status. So the status by default is pending, and here we have 4 statuses: pending, active, suspended, and inactive. So the flow of our application, as already shown in the demo of this video or of this course, so is that a tenant register to create an account in our SaaS application, and then the platform admin, or like the administrator of the whole SaaS application, he needs to approve this request. Once the request or this tenant is approved, we automatically provision the schema, we create the tables, and we do all what needs to be done. Once we do that, the tenant can access the application, can create users, products, stock movements, and so on and so forth. So for the tenant, we need also to have the admin full name. For example, we need to have the admin email, user mail, and username and password. All right, so like this is our tenant entity. Then we will create our user entity. So let me do that. So here we have user. So like this is our user entity, and for the user, it's going to be like a classic one. All right, so I can also paste the Lombok annotations in sorry, not this one, but yes, this one. And here let's call it users. All right, and then let's extend our abstract entity, and I will just fast forward and add all the attributes that we need. All right, so this is our user entity, and there is some dependency that we need to add before that, but let's go ahead and first check that. So here, what do we have? So we have a user. The first thing, we have a relationship between the user and the tenant, right? Because each user belongs to a specific tenant or to a given tenant. So for each user, we need to have our tenant ID, which is a relationship between the tenant and the user, and it's a tenant ID. So the fetch type is lazy, so it means when I fetch the user, I don't need to fetch the tenant information. And here just defined my foreign key name. All right, so then what do we have? We have like the classic information like the username, email, password, first name, last name, role, and enabled. All right, and of course there is something that we should not forget, that we need to extend abstract entity, and we need to implement the user details from Spring Security. For that, I will open my pom.xml and I will add a starter. So I will search for security, Spring Security, and add. All right, so now I can do implements user details. So the interface user details from Spring Security Core user details. All right, so here what do we have? So we have, as I mentioned, like this bunch of information: username, email, password, first name, last name, and we have a role. So this is our list of roles. We have a platform admin, we have role company admin, role administrator, user, and sales operator. You can add as many roles as you want or as you need to. And here, of course, when we implement these user details, we need to implement few methods like the get authorities. So the get authorities, we need to return an object or a list or a collection of granted authorities. And here simply, like, we need to return a list of simple granted authorities, granted authority this.role.name. All right, and here what do we have? So I just created another method just to retrieve the tenant ID from the user. So like I don't want to access user.getTenant.getID. Simply I created the method here called getTenantID to fetch the tenant ID. So this is our user. And then what do we need? Of course, we need to create the repositories. For that, we need to create the services. So let's go ahead and do that. So for the repository, I will create first interface like tenant repository, and here of course extends JPA repository, and then I need to pass my tenant and string. All right, so this is my tenant repository. And for the methods, I think I would need, because I know the logic and I know how, like the flow of the application, how is it going to be. So for example, when we want to create a new tenant, we need to check that the tenant exists by company code, or if we have like the tenant is already there by the company code, or the tenant exists by email. So in this case, we need to block that. So I will have a Boolean, and I will say exists by email, for example, and I will have another Boolean exists by company code. So company code. And these are the two methods that we need for the tenant repository. So next, let's create the user repository. So new interface, user repository. In the same way, extends JPA repository, and here we have user and string, so we import the correct one. And for the user repository, of course, we need to find few users. We need to define, not to find few users, but we need to define few methods. So the first one is exists by email, or let's call it a Boolean exists by email. And of course, we need a Boolean exists by username. All right, because in the user repository, I have the email and the username. So for example, like we can log in the user, whether by user email or like by email or username. All right. And in here, what do we need? So we need another method. So for example, like finding a user, by ID and not deleted, because we know that in the abstract entity we have the deleted flag and we will use that internally. But let's keep that for later. Like when we implement the service, if we need such methods, we will implement them. And then, so we need also like the requests and responses object. So we will implement that when we come to that part. So now I prepared almost everything. And now the next step, we need to start implementing the security. So for the security, we will implement an asymmetric encryption using private and public key. And I already showed that in one of my YouTube videos. So all you need to do is to go to my channel and in here, go to videos, and from here, just search for asymmetric encryption. All right. And this is the video that you need to watch if you don't know about asymmetric encryption. So I explained everything in here step by step, how to implement the asymmetric encryption and security step by step. So I will try to fast forward in this video because I don't want to repeat myself many times. As I mentioned, like I implemented security multiple times. All you need to do is to search for asymmetric encryption or simply search for security in here, and you will find all the Spring security videos that I created. So like there are like multiple of them. So, and as I mentioned, I recommend for this video that you search or you watch at least the asymmetric encryption part to know or like to learn how you can generate the private and public key, what are the services required, and so forth. All right, with that being said, we can move on and continue the implementation of our security. All right, so now let's start implementing security. So for the security, we need to add few dependencies first. So we need to add the dependencies that will allow us to generate the token, decrypt it, extract claims, and so on and so forth. So from here in the pom.xml, I will scroll down, and after security, I will paste this one. So it's JWT API implementation and Jackson. Don't forget to click on sync Maven changes to download all the dependencies. Otherwise it will not be available. So the next step, I will create a security package, and then I will create my security config. So I will create security package and then security config. So this is the configuration of our security. And the configuration, it looks something like this. So let me just provide it in here, and then I will explain it step by step. All right. So what do we have? So we need to create a class. We need to give it the configuration annotation, enable web security, and enable method security because we will need that later on. And then I defined a list of public URLs that I want to authorize. All right. So here, like from here to here, these are like all of them or most of them are the Swagger configurations or the Swagger resources that we need to permit or to authorize because they should not be secured. Okay. And here I only authorized my API/v1/auth because the login and the register also, they do not require a token. And then we will create in the next step our JWT authentication filter. So we will come back to this in a few moments. So here, what do we do? Or like, what do we need to do? We need to define a bean of type security filter chain, and it takes as a parameter HTTP security. All right. So the first thing, I just disabled the CSRF, which is like the cross-site resource forgery. And I defined a course bean because our application will be consumed by Angular, so we don't want to have this course issue. So I will also go through the configuration in a few moments. And here, this is the part where we authorize the different requests, so like how we want to handle the request authorizations. So here we have public routes. So for any request that matches these public URLs, I want to permit all. Also, any request matchers of type option on any resource, I want to permit it as well. Otherwise, all the other routes, they require authentication, like to access the users, to access the categories, products, and so on and so forth. All of them, they must be authenticated. And then I defined my session management policy to stateless. And finally, I added a filter before, which is my JWT authentication filter. So this is the one that we will implement in the next phase. So now let me go through the course configuration source, or the course configuration bean. Again, it's a bean. And then what do we need? So we need a course configuration. So I'm just going through the things that I already showed before, but later on we will implement the multi-tenancy step by step, and I will explain every line of code as always. So here we just need to define a course configuration, and here we need to set the allowed origins, allowed methods, allowed headers, if we want to allow credentials or not, the max age, and so on and so forth. So the allow credentials true, I will comment it out because we don't want to authorize that, especially in the case of an Angular application. And then for which pattern we want to register this configuration for any incoming request, or any request we want to register this course configuration. And now the next step is to implement our JWT filter. So in the same package security, let's go ahead and create our JWT authentication filter. All right. So this is the code of our JWT authentication filter. I will go through it step by step, and then we will continue implementing, or we will implement the parts that we need to implement. So what do we have here? We have our token service, and we have a tenant schema resolver. So the tenant schema resolver is exactly, well, it's something different. So we will set it later on. And we will implement it like in the next phase, or in the next step, but don't worry about that. I will explain everything. But the JWT token service is a classic one, so we will implement it, or like I will show you the implementation really quick. But let me first go through this one. So the do filter internal, so it's a once per request filter. We need to annotate it with components. Also, we need the required Args constructor so we can inject the different Spring Beans, and we need to override our do filter internal. So we receive or we pass three parameters: the HTTP servlet request, response, and the filter chain. So like this is exactly the same as the previously implemented Hibernate tenant filter. Sorry. So this is exactly the same. So this is why we casted the objects in here. So what do we do? The first step, we check if the request is for the auth, is for the authentication or login or register. We don't need to do any checks. All right, we just need to call the filter chain.do filter. So this means we want to execute or to call the next filter in our filter chain. Then what do we do? So we get the JWT from request. So this is like a classic and simple method. So we get the authorization header. We make sure that the authorization header starts with a bearer. So just to say it's a bearer token. If it's the case, we just return authorization header.substring 7, because if you can't count from here to here, or from the position 0 to here, there are 7 characters. All right. Otherwise, we return null. So once we get our JWT, we just need to make sure that the JWT token is not null, and we need to make sure that the token is valid. All right. So we need to validate the token, and then we need to extract few information. We need to extract the user ID, the tenant ID, and the role. All right. So we will come back, like when we implement the JWT token service, all this method, they will be there. So now we do a check. So this is exactly the same as our tenant filter in here. So if we have the tenant ID, we just store it in our current tenant context. Okay. So then we store the tenant in the context. All right. So then what do? We need to resolve the schema name. So resolving the schema name, because we said that for each tenant we need to create a specific schema. So we will implement this one, and I will explain to you step by step what do I mean by that. So now we have in the tenant context, we need to extend this one and to create a new object or a new thread to store the current schema. All right. So how to do that? I will just go to the tenant context. I will duplicate this one, and here I will call it current schema, for example. And in here I will just duplicate these two methods. So let me duplicate this. So here, let's say set current schema. So set current schema. And here we need to use current schema instead and get current schema. And we need to use current schema. And of course, we need to duplicate this one, the clear, or well, we don't need to duplicate this one because in the same method, when we clear, we want to clear both. So we want to clear the current schema as well. So if we go back in here, so now this error is gone. And the rest is really classic. So we just create like a simple granted authority. We create an object of username, password, authentication token, and we pass the user ID like with null credentials, or you can even pass the JWT token as credentials in here if you need it somewhere else. Also, we set the details and we update the security context. All right, and that's it. So, and then in the finally block, or even after that, once the request is done, we just need to clear the context, like the tenant context. So this will clear the schema and the current tenant ID as well. So first, let's go ahead and add this JWT token service, because as I mentioned, like it's really simple one. All right, so our JWT token is there. So, and as you can see, let me optimize all the imports. Yes, this one we will need it later on once we create the tenant schema resolver. So, but let's go through the JWT token service. So what I did in here, so I created a JWT properties. So it's a class just to read the properties that we have in our application.yaml. So we have app.jwt. So this is the prefix app.jwt. And then I want to automatically inject the private key path, the public key path, and the access token expiration. So these are the three attributes that I defined in here: private key path, public key path, and access token expiration. All right, so let's go back to the token service. So here I created two objects, one of type private key and the other one from public key. So the public and private key, they are from java.security package. All right, so like no extra package is required in here. So here I created a post construct method or an init method, and in here I just need to load the private key and the public key. So the private key and the public key, as you see in here, they are defined under a folder called certs/private key and certs for certificates /public key. And this is what you see in here. So we have certs, private key, and public key. So let's go back to this. And as I mentioned, like I explained all that in step by step in the asymmetric encryption video. So just, I really recommend, if you don't know about the asymmetric encryption, just go ahead and watch that video. So here I load the private key and the public key, and simply I have a method called generate access token, and like I simply pass the tenant ID and the user ID and role. And then I just create an expiration, or calculate the expiration based on the token expiration, like the one that I defined. And simply I set the subject, which is my user ID, and I set a list of claims. So the first claim is tenant ID, the role, the issued at is now, the expiration when this expires, and the issuer is stock SaaS app, for example, or inventory SaaS app, like you can call it whatever you want. And this is the most important part. You need to sign it with the private key, all right, using the algorithm RS256. All right, then what I defined also, like I have methods to extract the user ID from the token, tenant ID from token, role from token. And here I have the method validate token, and here it's only claiming about an authorized exception, which is a custom exception that we need to create. So we will implement that, or like we will go through that in just a few moments. And here we have a method get claims from token. So these get claims, simply like we need to parse the token and verify it with the public key, and then just we parse the signed claims and get the payload. All right, and the method load private key and load public key, they are the same, almost the same method. So all I did in here, I have a try with resources, so an input stream. So the JWT token service.class.getClassLoader. And here, so the get class loader, it will point you exactly in here, all right? And then get resource as stream, and then you need to pass the path, right? So because as you see in here, the path is under search/private key.pm. So here, as I mentioned, get class loader will point you under resources, okay? And then when you pass the path, it will read the subfolders that we have there. So if the input stream is null, we raise an exception. Otherwise, we read the key. And then, so here, let me explain what I mean in here. So for the private key, you see, we always have begin private key, and we have end private key. So we need to replace that or to remove these two lines because they do not belong to the key itself. All right. So they are just comments mentioning where the key starts and ends. And then we replace all the spaces or like all the line breaks with an empty one. Then we just need to use the base64 encoder, and we just need to encode the private key. And then we need to return a Pixie S8 encoded key spec, and simply we need to get the instance of type RSA or like using the RSA algorithm and generate private key. This almost the same for the public key. So we just need to read from the resources. We check if it's not null, and then we read the bytes. We replace also like the begin public key and end public key because both of them. So here it's begin private key, and the other one for the public key, it's begin public key. We encode it using base64, and then for that we need to use the X509 encoded key spec. All right. So we also use the RSA algorithm instance, and then we just generate the public key. All right. So next, let's just try to finish or finalize the common parts, and then we will come back and start implementing the tenant schema resolver. All right. So what I will do next, I will create the exceptions because we need them almost everywhere. So let's create the exceptions, and then we move on with the rest. All right. So now let's add these exceptions, and let's add also the exception handling part. So here I will create, so let me close all this, and I will create a business exception in exceptions package, and I will call this one business exception. All right, so this business exception, like simply it's going to be an exception that extends runtime exception. And I will add a getter annotation in here. So I will have a private final string message. And then just we need to call the super with this message and then assign the message in here. So if we go back to our JWT token service, we see here that we do not have this. We have this unauthorized exception, but it's not yet defined. So how to do that? I will simply create the class under exceptions, and this one. So I will extend simply my business exception. All right. So and here I just need to call the super with token has expired. So well, I will call it just message, just as a short name. And in this way, our JWT token service is clean and without errors. So also in here, if we go back, for example, for the services that we implemented. So here, let's say, for example, maybe product or category, whatever. So here, maybe instead of throwing a runtime exception, just like runtime exception like that, what we can do, we can create another exception in here. So let's create an exception and let's call it duplicate resources or resource exception. All right, so duplicate resource exception extends business exception, and then we just need to call the source, the super class. So here resource exception, and here instead of runtime, let's say duplicate resource exception, and that's it. Let's check, maybe we have somewhere else or another place to add it, and we're good. All right, we can just copy paste this one in all the other services, like also for product. So here instead of runtime, we can also return a throw. We can throw a duplicate resource exception, and then the same way in here, if we have runtime exception. So we don't have in stock movement. So since we are in the exception area, so let's also add other exceptions, or maybe let's add our global exception handler. So I will create a class global exception handler. So this will be our global exception handler class. And here all I need to do is to add a REST controller advice and SLF for J for logging. So let me rename and fix the typo. So exception, and in here I will handle few exceptions. All right. So I will copy paste the code. I have it already in one of my repos, and here let's see what do we have. So here we need an object of type error response. Okay, so error response, let's create this class in here. So sorry, not import, we need oh, come on. So more actions, let's create class error response under exceptions, and I will create a sub package called responses. All right, so this class simply, it will be like a Peugeot class that contains few information. So here I will have a private string code, so like the error code, and private string message, and also I can add a private string path, and finally I can add a private list of validation errors. So this is something that we will create. So validation error, not errors, and let's call them validation errors. So this we will use it when we create the validation errors. So for that, what we need to do, I will create a public static class validation error, and this validation error, it will contain these fields. So I will have a private string field, message, and code. All right, and private string code, for example. And then I will add some Lombok annotations, and as well here I need them also on the validation error part. So this is our error response, and from here we have our error response. And let's maybe go through the different exceptions or the different handling that we have. So here we have a business exception. So we try to catch any business exception that might occur in our application. So any business exceptions, like any business exception and all the derived classes from business exception, like unauthorized exception or duplicate resource exception, or any other exception that we'll create in the future. Like simply we need to inject the exception, and also we can inject the HTTP servlet request to get the information or the request URI from the request. So here we just build our error response object. So here we get the message, we get the path, and then we build. And here we need to define or determine or to resolve the status. So depending on the exception type, we will resolve or determine the status, and simply we need to return this. So the get HTTP status. So what do we have? So here, if my exception is instance of duplicate resource exception, so this will be a conflict. Unauthorized exception, it will be unauthorized. And later on we will need, for example, like tenant provisioning exception, because we need to implement the tenant provisioning. So let's create this one in here, and extends business exception. And let's add the constructor. And then we have also invalid request exception. Let's create it in here. Let's extend our business exception class and add the constructor for that. All right. So now let's go back and finish and continue in here. So as I mentioned, like if it's of type unauthorized, so we return HTTP unauthorized. If it's a tenant provisioning exception, we can return internal server error, for example, or invalid request. So we return a 400 or a bad request. And we have here, for example, like a default one, which is if it's not part of these different exceptions. So we simply return bad request. And then since we will add also, we will add some other exceptions, or like the validation for our different inputs. So we need to catch the method argument not valid exception. So I also explained that many times in my different videos. So that's why I'm trying to go a bit faster, because I want to focus on the multi-tenancy approach. All right. So, but we need all those building blocks for our application to work end to end. All right, so here what do we need to do? So I will create a list of validation errors, so the one that we created in here. And then what we need to do, so from our exception, because we want to catch a method argument not valid exception, this is the exception that will be thrown when we add, so for example, in our controller or any controllers we have, since we have this valid annotation, this means that any exception or any validation error that will be raised in this object in here, we will raise or we will throw, or Spring, exactly like Spring will throw a method argument not valid exception. And from that, we can get the binding results, get all errors, and for each error, we want to extract the field name, the error code, and the default message. All right. So what do we have in here? We have the field. So field, like simply, we need to cast this error in here. So like we are looping over the list of errors. It's of type object error, and we can cast it to a field error. All right. And then get field. So this will be our field name. And then we have the error code, default message. And then simply we need to build the validation error object. And finally, we just need to return our error response. So we set the validation errors and we set the path, and simply we return a bad request. Also from Spring Security, so this is another handling. So from Spring Security, when the user types like a wrong username or password, so Spring will raise bad credentials exception. So in the same way, we pass the exception in here, or simply we just return a message or a response saying that login and or password are incorrect and it's unauthorized. And that's it. So like it's as simple as that. So this is the exception handling part. So what we still need to implement next. So next we need to implement, so this is where we will go back to the real implementation, writing the code line by line and so on and so forth. So what we need to implement, we need to implement the tenant service. So we don't have it yet, but we will create our tenant service and our user service. So first we will start with the user, since this is the one required at least by Spring. So we will start with this one, and then we will implement the tenant service as well. So let's move on and continue with that. All right. So now I will create a new interface in here. So now like we are back to really implementing the code ourselves. So I will create a user service interface. And this user service, you know that Spring Security needs an object or needs an implementation of the user details service. So simply we can extend the user details service from the Spring framework. All right. So, and then I will define, so I will not extend the basic or the basic service, because I want to define some other methods in here. So I will create our first method. So let's call it create user. And for that, we need a user request. So here we need user request object. Let's call it request. Let's go ahead and create the user request first. So let's create the class in requests. So we will come back and define the attributes later on. And I want another one, update user. So it takes a user ID and a user request as parameters. I want to void delete user by ID. And also I want a user response. And let's call it, for example, get user by ID. And here we need to pass a final string ID or user ID, like you can call it whatever. So let's go ahead and create this user response object in the responses package, and we will come back and add the attributes later on. So also I want a page response. So a page response of user response, let's call it get all users, and then we need to pass a page and size. And finally we have, for example, enable user. So we want to enable the user, and we need to pass the string ID, and also disable user, we need to pass as well the string user ID or ID. All right. So if you want to, we can just rename those two. So let's call it user ID. All right. So now we have almost all the methods. So simply let's go ahead and add the user request and user response. So for the request, I need, of course, my getters and setters. So this is the first thing, and then I will define a private string username and private string email. So this is what we need to create a new user. We need a private string username, of course. We need a private string, not protected, but it should be private string password. Username. So username was defined twice, so let's remove it. So we need the password, and we need a private string first name and a private string last name. And finally, we need to pass, well, not a string, we can use the user role if you want to. So we can use the enum as an object or of type of role. So for the user response, so it's also simple. So the user response, we will have few information. So first, let's paste the Lombok annotations. And here, what do we have? So we have first a private string ID. So this will be our user ID, and then private string username, email. We have in the response, so we don't need the password. So we have also a private string first name and last name, and finally we can add the user role. So this is our response object. And also there is one thing I need to make sure. Yes, so here we have the ID, and I think I don't have it in product stock. And yes, okay. All right, so now we have our service. So let's move on to the implementation. Let's implement our user service. So here in implementation, I will create a new class called user service implementation. Simply, this is a service, and this is required args constructor, and SLF for J for logging. All right, so now we need to implement user service. Now I need to implement all the methods. So here we have create user, delete, and so on and so forth. So let's start with the first one, which is load user by username. Okay, so simply I need first to inject my private user, not user service, but private final user repository, or let's simply call it repository as a shorter name. All right, so here what I need to do, return this dot repository dot find by username. All right, so find by username, and I need to pass the username. So here, for example, if you want to support username or email, you can add or create a method find by username or email, and you pass this username, and this should work. All right, and here or else throw, and in here I need to throw, so it's a lambda expression, so new user name not found exception. And for example, I can say no user was found with ID, for example, and here, or username, sorry, not ID, but just username. So we don't have this method, so let's go ahead and create it. So it's like an optional method, like nothing really fancy. So it will be an optional of user find by username. Let's import the optional from the Java utils. Let's optimize the imports, and that's it. So this is our find by username method. All right, so now let's go ahead and start implementing our user service. So let's start with create user. So create user, first we need to grab or to get the current tenant, right? So here I will have a final string, let's call it tenant ID equals tenant context dot get current tenant. All right, because when we create or when we insert something, we need to get the tenant from the context. All right, so then what do we need to do? So if this dot repository dot exists by username, so we want to check that whether do we have another resource or another user in our database with the same username. So all I need to do is to throw new duplicate resource exception. Username already exists, for example. All right. So here let me add some comments so you can follow up. So here validate if username already exists. The next step, I need to validate if email already exists. Okay, nice completion. So if the email already exists, so I need to raise email already exists. So now I need to validate the role. So validating the role, so this cannot be platform admin. All right. So this means what? Because like this endpoint or this service will be used by the tenants themselves to create their own users, right? So you cannot use the role platform admin. Otherwise, this might give you some extra roles or like permissions that you should not have. All right. So here I think the auto completion was not fine. All right, I will delete that because this is going to so if my request dot get role and then equals my role or like user role, not role user but role platform admin. All right, if this is the case, I want to throw a new and valid request exception. So this is the request that we created before. All right. So platform admin cannot be created or cannot be, for example, selected as a role if you want to. All right. So once we have everything, all I need to do is final user, without a comment, but final user, let's call it user equals this dot, I need to inject or create my user mapper. So private final user mapper, I don't have it yet. Let's call it user mapper. So let's go ahead and create this class in mappers. Let's give it the service annotation and we will get back and implement this one. So this dot user mapper dot to entity, and we need to pass the request. Once we have that, so we say user dot set tenant. So let me import this one. So set tenant, and the tenant is this way. So tenant.builder.id.build, as simple as that. And finally, this .repository.save. And for example, we can add the log.info, user created successfully without even printing the user created successfully. And that's it. So now let's go ahead and implement the toEntity method. So this should return a user. And the toEntity method is also like a simple mapping method. So we should return user.builder.build. And in here, we need to set the username. We need to set the email. And then we need to set the password. And we need to set the role. So the role is request.getRole as well. And finally, first name and last name. So let's go back in here. So now we need something. So here when we set the password, so we have two options, whether to delegate the encryption to the mapper, or we can do it in the service. All right. So I want to keep my mapper clean. So what I will do in here, so I will inject my private final password encoder. Let's call it password encoder. So for now, I think we don't have the bean yet, but we will create that. So what I will do in the config package, I will create a class. I will call it beans config, for example. All right. So this will be a configuration. And now I will create a bean of type public password encoder, and simply I will return a bcrypt password encoder. All right. So now what I need to do after mapping the user, setting the tenant, and also like user.set password, this dot password encoder dot encode, and then request.get password. All right. And in this way we have, or like we just implemented our user or create user method. So let's move on to the update user. Also, this one is a classic one. Maybe I can like code it in the background and explain the code. This might be faster or clearer for you. So let's do it this way. All right. So now let's check the update user. So as always, I get the tenant ID from the tenant context. So updating, just logging here, updating user for tenant ID. And then what I need to do, I need first to find the user by its ID. All right. And the user should not be deleted because we have the deleted flag. All right. So final user, find by ID and not deleted. And this is the method. So like it's a simple one, select u from user u, where u.id equals the ID that we pass as a parameter, and u.deleted false. So like it's a simple method as I mentioned. So first we need to check that the user belongs to the tenant. That's why we need the tenant from here. Okay. So if not, the user.getTenant.getID not equal to the tenant ID. And here I think we can use directly the get tenant ID. So get tenant ID. So this is the method. If this is the case, we can raise invalid request exception. All right. So then we need to check if the username is being changed. If it is the case, we need to check, or we need to verify that the new username does not exist. So the check is if the username is not the same as the new username, and the username, like the new one, does not exist in the database. All right. So if they are different, and if the new username already exists, so this is a duplicate resource exception. Then we need to do the same check for the email. So this means if the email is being updated and the new email already exists in the database, we also throw a duplicate resource exception. Then we need to do the same validation for the role. So if our role is platform admin, so here instead of role is required, let's say the user role cannot be platform admin, for example. Otherwise, we just update the details. Okay. So for the password, or for updating the password, this should be a completely different process, and I already created a video about that, how you can implement change password or update password. After that, I just updated the details, and then just repository.save. So now we will implement the delete user, and this will explain to you why I created this method, because the delete user I want to implement a soft deletion, not a hard deletion. Okay. So like a soft deletion means that I just want to update the flag and save the user. So let's go ahead and implement this one. So, okay, I think this one is not so long. So first, final string tenant ID, and then we need to find the user. So deleting user for tenant, and then we need to find the user and make sure that it's not deleted. And then we need to do the same check. So here, check if the user belongs to the tenant, because just even if we know that the front end might help or might secure this part, we always need to make sure that we are not deleting a user that belongs to another tenant. So here, so it's a soft delete user. So soft delete means we only switch the flag to true, and then just save the new user. So like it's a deletion, but in the core it's only an update. It's not like a real or a hard delete. Okay. So next one, what do we need in here? So we need to implement the get user by ID in the same way. So final string tenant ID, and then we need to get the user. So final user equals get this dot repository dot find by ID and not deleted, and we pass the user ID, and here or else throw user not exist, or user does not exist. And then we need to perform the same check. So I still have it here. So we need to check that the user belongs to the tenant. If the user does not belong, we need to throw an invalid request exception. And finally, this .mapper to response. So we don't have this method yet. So let's go ahead and create it. So let's create the method and simply return user response .builder.build. All right, so here we need just to set the different values. So here first we need the ID. Here it's response, not request. So .id, so it's user.getID, and then we have username, and we have the email, we have the role. So .role, it's user.getRole, and we have the first name. So we have the first name, and we have the last name. All right, so username, email, role, first name, and last name. And that's it. So now we just need to implement the get all users. So this is also, as I mentioned, like we already implemented that before. So it's a simple one. So get all users. So first we need the tenant ID, and then we need a final page request object. So it's a page request.off page and size. And then we have a final page of type user. And this one is equals to, let's call it user page, for example, equals this dot repository dot find all by tenant ID. So in this case, or in this time, we need to add this filter, or we can also keep the first approach and enable the filter for only specific entities. All right. So find all by tenant ID. I need to pass my tenant ID and my page request. So let's go ahead and create this method. So it should return a page. And then this method is simple, like it's really simple. So I will just create a query. So the query is, okay, so the auto completion works really fine. So select you from user, where u.tenant, or like user.tenant.id equals the tenant ID that we pass as a parameter. And then the u.deleted is false. So I don't to get all the non-deleted users. All right. So after that, what do we need to do? We need to map. So here I need a final page of type user response, and then user page dot map, and we just call the mapper. And finally, we return our page response object, and we call the dot off method, or the off method, and this will automatically map or return a page response to our end customer. All right, so now let's implement the enable user method. So in the same way, final string tenant ID, and then we need to find the user, make sure that the user already exists. And in here, we need to check that the user belongs to that tenant. If this is the case, user.set enabled, so here not deleted, but set enabled to true. And finally, save user. And here, for example, user enabled successfully. I can copy paste all this code and paste it in the disable user. So the disable user, we only need to switch the flag in here. All right, so you can even extract this code and put it in a method. So here, let's say disabled successfully, or deactivated, or you can call it whatever. All right, so now we have our user service implementation. Then we can move to implement, or like we can move to the implementation of the tenant service. After that, we will implement the security, and then we will continue the application and move to the front end part to have a completely, or like a fully working application that supports multi-tenancy, and it's going to be a SaaS application that supports multiple tenants. All right, so now let's move to the implementation of our tenant service. So first I will start by creating the tenant service interface. So tenant service, and here I will define few methods. So void, we have first register tenant, and this should take a final register tenant request. So let's call it request. We will create this one in a few moments, or let's go ahead and create it right now, and we will define, so here requests, and we will define the attributes later. So then we have a void approve tenant, and we need the tenant ID as a parameter. We have a void activate tenant with a tenant ID, a void deactivate tenant, and a void, let's say just suspend tenant without deletion, and a page response of type tenant response, and let's call it find all. So find all, and we will have final int page and size, and final int size. Let's go ahead and create a tenant response object. So create class in responses, and let's fill out this later on. So let's start with the register tenant request. So the register tenant request, let's open our tenant class. So tenant.java, yes, this one. So what do we need? We need the company name, and then we need the company code, we need the email, and we need the admin information. So the admin full name, admin email, admin username, and admin password. So let's copy those and put them in the register tenant request. So let's paste this, and also let me paste the Lombok annotations. I think I have one here. Yes. All right. So now we have our tenant register request. We will add the validation later on. And now let's add the tenant response. I guess I can copy this, and in the same way. So let's just check. So we need here the private string tenant ID. We have the company name, company code. We have the email, the admin full name, email, username, and password. So I guess the password, we don't need it. Like, it does not make sense to expose the password. So private, I will add a private local date time. So private local date time, if you want to create it at, like when this was created, and a private tenant status. So this will be the status of my tenant, because the platform admin needs to approve based on the status, and of course we will have logic in the front end based on the status. So this is our tenant service. Let's go ahead and implement the different methods of our tenant service. All right, so here in implementation, let's create a new class. Let's call it tenant service implementation. All right, so let's give this one the service annotation. So service and required args constructor and SLF4J for logging. And here implements tenant service. Let's go ahead and implement all the methods. And now we will start implementing them one by one. So first I need to inject my tenant repository. And then I need also to inject my tenant mapper. So private final tenant mapper. We don't have it yet. Let's call it tenant mapper. We need, of course, our password encoder. So let's private password encoder. I think IntelliJ is hearing me or so. All right. So we need our user repository, and later on we need another service. We will implement it later on, which is the one, if you remember, if I open here the authentication filter, which is our tenants, not tenant schema resolver, but we need also like a provisioning service to provision the database and the schema for the user. So let's create a tenant mapper first. So let's create it in mappers, and then let's give it component or service. It's the same. And here we will create the methods later on when we need them. So let's go ahead and start implementing the first method. Let me close all this. Let's start implementing the first method, register tenant. So what do we need to do first? First, we need to check if the tenant already exists by company code. All right, so we need to check if the tenant already exists by company code. So if this is the case, so here I will raise a duplicate resource exception instead. Then we need to check the email. So the next step is check if email already exists. So if email exists, sorry, not user repository, but tenant. So tenant repository dot exists by email. So email already exists, or like tenant, just to be precise, tenant email already exists, or tenant here already exists, and here tenant email. So this is fine for me. So then simply I need to create the tenant entity. So how to do that? Simply final tenant equals this dot tenant mapper. So let me import the tenant first, and here dot to entity. And to entity I need to pass the request. So then let's move on with this. So set admin password is this dot password encoder dot encode my request dot get admin password. All right, so we need to encode the password, and then tenant dot set status. I want to set it to tenant status dot pending, so it should be pending. And finally this dot tenant repository dot save. So let's go ahead and implement the to entity method. So the to entity is like, as I mentioned, like it's a really simple mapping. So let's return a tenant object dot builder and then dot build. Dot builder dot build. So what do we need here? We need the company code. So let's say company code, and here we need company name. Let's say company name, and we need, let's say for example, created at local date time dot now. Then we need the email. So we need email. We need the admin. So dot admin full name. Admin email, is it duplicated? Nope. Okay. So admin full name, and we need also the admin email. So this is the admin email. Okay, we did it already, and the admin username instead. So admin username. And finally, let's set deleted to false, because we don't want it to be deleted by default. So this is the first method. Let me also at the same time create a public tenant response to response from the entity, of course. And here I guess I can copy this one and only change the types. So here a tenant response, and here I can just call this one request, and now I can rename it to entity. The deleted, we don't need it. We need here the tenant ID. All right. So I guess we have everything, or all the information when it comes to the front end. And if we miss something, we can come back and finish it. So now we have our registered tenant. So then we need the approve. So what to do exactly when we approve a tenant. So this is the most important part. So when we approve a tenant, what we need to do. So other than changing the status, we need to provision the tenant. We need to provision the tenant. This means what? This means that we need to create the schema, create the tables. All right. And if, for example, if we want to initialize some data, because like the scope of this application is too small, but in other applications, you need, for example, to provision some data, insert some, I don't know, like let's just an example, insert some basic categories and so on and so forth. So all this needs to happen in the same time. All right. So here, let's do this step by step. So first check if the tenant exists. So it's going to be tenant.findById. All right, or else throw. Yeah, but I need to throw something. So new entity not found exception, and tenant does not exist. So then we need to set the status to active. All right. And then we save the tenant. So what we need to do next in a try and catch block. So try and catch. So here I will catch any exception. So final exception. And here I will tell you or let you know what we need to do. So here, what do we need? So we need to call another service. So a service I will create. So I will create a private final, and I will create a service I will call it provisioning service. And let's call it provisioning service. So the provisioning service, we don't have it yet, but we will create it in a few moments. So let's go ahead and create this first. So let's create it as an interface and directly under services. All right. So this is our provisioning service. Let's implement this one, and then, okay, so let's implement it in a few moments. All right, wait. So here in this provisioning service, I need a void called provision tenant. All right. So provision tenant, and this will take a final tenant object. So tenant. And let's import this one. So import class, and let's create the implementation, and we will come back to the real implementation later on. So tenant provisioning service implementation. All right. So implements tenant. Is it tenant or provisioning service? What did we call it? Where did we create it? This provisioning service. Okay, it's here. Let's also rename this one to provisioning service. So let's call it, or implement provisioning service. Let's implement the methods, and I will rename the class just to be compliant. All right, provisioning service implementation. Let's leave this one and we will come back to it later on. So here we have our provisioning service, and we just need the service annotation, required args constructor, and SLF for J. Wrong spot. Optimize the import, and it should be on the implementation. All right. So now I guess, yes, we are good to go. So let's go back to this try and catch block. So this try and catch block, all I need to do is to call. So here, let me add some comments. So provision the schema. So this is what we want to do. Provision the schema for the tenant. All right. So this dot provisioning service dot provision tenant, and I simply need to pass the tenant. But if something happens, if something wrong happens, I need to roll back. So then that's before rolling back. So here we need to create the admin user for that tenant. Okay. So I will create a method. I will call it create initial admin, or create admin user, or whatever. So create admin user, and I simply need to pass the tenant. So let's implement this method first. I will just move it to the back and to the bottom, since this is a private method. So this is like really simple implementation. So first thing I need to do is check if the user already exists. So if the user already exists, so like tenant.getAdmin user, if this one already exists, I need to raise a duplicate resource exception. All right. Okay. You might say, yeah, because in the creation we do this check, but never trust any layer. So like in each layer, you need always to apply the security that you need. So now let's create our user object. So it's going to be admin. Let's call it admin user equals user.builder.build. All right. So for this one, we will set the username. We will set the email. So tenant.getEmail. We will set first name. So for the first name, I will create two methods, extract first name and last name, because we know that we have, okay. So let me show you what I want to do. So extract first name from tenant.getAdmin full name. All right. So let me create this method first. So extract first name is simply return admin full name dot split 0. Dot split with a space, because we know a full name it will be with a space, and then we get the first one. So even like, because we know the admin full name is always there, so we always have the admin full name, so this will never return any null value. All right, so then we need the last name, and I will create another method, extract last name from the tenant.get full admin full name. So let's create the method, and the method is also simple, so extracting the last name. So here all I need to do, so let me do this one. So all I need to do, so admin full name dot split. So here I will do some check. So dot split with a space if the length is greater than 1, so I return split and get the first one, otherwise I return the admin full name. All right, so this is my like the how to build the last name. So then we have the password, so it will be our tenant.getAdmin password. So the admin password, we don't need to hash it again because it is already hashed. So when we create, or like when we register the tenant, we already hash the password. All right, so we don't need to hash it once again. And then let's give it a role. So for example, let's say user role dot it will be a role company admin. All right, and let's set the tenant, and let's say deleted false. All right, so this is our admin user. And finally, this .user repository .save admin user. All right. And then, for example, we can say log.info admin user created successfully for tenant, and so on and so forth. So this is the create admin user. But there is something, as we mentioned. So here, when we try to provision a user, but this does not work, and in case something happens, we need to roll back. So roll back tenant status. All right, so we need to roll back the tenant status, and we pass the tenant as a parameter. So this rollback tenant status, it's a method that will do the following. So tenant.set status to pending, and this .tenant repository .save tenant. All right, so now what do we have? We have like the approved tenant process or logic completely implemented. So I will move this one to the bottom in here since it's a private method. And now we can implement, or like we can finish implementing the activate, deactivate, and suspend and find all. All right. So this is like this will be easy methods. So here for activate tenant. So let's get the tenant. So final tenant. Let's call it tenant equal this .tenant repository .find by ID or else throw, and then we need to check the status first before setting it to active. So if tenant .get status if not pending. So here if the status is not pending, so what we need to do, so we need to throw a new, not a legal exception, but we need to throw a new invalid request exception, because if the status is not pending, we cannot activate a tenant, because the activation should only go through the approved tenant, because we need, like in that case, we need to provision the schema. Otherwise, we should not pass through that one. All right. So let's copy this code in here and paste it in the deactivate and just change what needs to be changed. So we first check that the tenant exists, and here instead of checking the pending, we need to check the active. If the status is not active, so this means that we cannot inactivate the user or the tenant. All right. So this is what we need to do. And now the same way, let's implement the suspend. So also when we want to suspend the user should be active first, and then we can set it to suspended. All right, so now with the last part, we need to implement the find all. So the find all is super easy. So here I need a page request object. So page request, let's call it page request, and here final page, find all, we pass the pageable, we map it, and finally we return a page response.off. And that's it. So now our tenant service implementation is done. But still the most important part, so user repository, so this one should be final, of course. So here we need to implement the provisioning service. So the provisioning service is one of the most important building blocks of our application. But don't worry, it's not the end. We still have so many building blocks to finish in order to route our requests and so on and so forth. So don't worry about that. We still have so many code to write. So let's move on and implement the provisioning service together. All right, so now in order to successfully and easily implement the tenant or the provisioning service, we need to do some changes before that. So here what do we have? We have under resources, we have database migration.common. All right, so like this is the common part where we need to create the so this is the first version, right? So like the common, this is where we create the categories, products, and stock movements. All right. So, but now the common should change because the common part is tenants and users. All right. So like these are the two tables, tenants and users. So what do we need to do? So here in this common, so let's keep this one in common, and then I need to create another folder. So I will just do it with the command line because if I create it through IntelliJ in here, it will not work. So let me check what do I have in here. So okay, so go to source, and then main, and then resources, and then DB, and then migration. And in here, let's create a folder. So make directory, let's call it tenant. All right, so now it looks this way. So for the tenant, let's move this one in under tenant, okay? Because this is the tenant part. And the common part, I will create a new file and I will call it v1 underscore, and let's call it init common tables. All right, so the init common table simply creating the tenants and the user table. All right, so I will just provide you the code in here. Sorry, I just forgot to add .sql. So this is the SQL syntax or the SQL code to create the tenants. So we have deleted, created, add, admin email, full name, and so forth. And the same for the users. So here, this file in here, I will rename it and I will call it init database for tenant. All right, so I will call it init db for tenant. So for tenant.sql, and here there is something really important. So here it worked before because the public schema already exists, but we need to remove it now. So we need to remove all the occurrences of public dot, because we don't have any schema yet and we want to execute that against the schema that we will create afterwards. So let's go back in here and let's double check our properties if we have everything. So yeah, this one points to the migration/common. So this means what? So this means if I delete this database, so if I delete everything from here, so object action and then drop, and okay, unfortunately now we cannot start the application because we still have some compilation issues in our authentication filter. But if I run the application at this level, so this will create the common table. So this will create only the tenants and the users tables, right? Under this public schema right here. But the other three tables, they will not be there. So just talking about that, we need to update this to none. Don't forget that. All right. So now let's go back to our provisioning service implementation. And now you will see, so what I want to show in here, so here we have our Flyway configuration. So this runs automatically when you start up the application, but how can you trigger, or how can you execute this manually or from the code? Okay, so this is what we will see in this part. So let's go back now and open our provisioning service and start the implementation. So the implementation is simple, to be honest. It's not really complicated, and I will explain it line by line. So first we need to inject our private final JDBC template. So JDBC template, so it's the one from Spring. Don't mix that one. So because the JDBC template, I think there is another one from Flyway. Exact. So you need to import the one from Spring framework. Otherwise, the code might not work. And then a private final. I need also to inject my data source. So again, from javax.sql, and let's call it data source. So the JDBC template and the data source, you will see what we need to do with that. So here we receive a tenant as a parameter. So first of all, I will create a final string. Let's call it schema name equals. So I will call it this way if you want to. So it will be tenant, and then it will be tenant.get company code .to lowercase. All right. So I will use the company code as the schema name. So it will be tenant, for example, like MS company or Alibu company or something like that. Why I don't want to use the ID, because the ID is of type UUID, or like unique unified ID, and it's going to be too long. But from the company code, I can identify the schema quickly. All right. So like rather than trying to find a random ID. So let's have a try and catch block in here. So first of all, I will add a log.info. So log.info, let's say provisioning tenant with company name. And here maybe we can add the schema. So the schema is the following, and here let's say schema name, just to be able to log or to check later on. So here we will have mainly 3 steps. So step number 1. So step number 1. So create the Postgres schema. So this is what we need to do first. Then next step is run the Flyway migration for this schema. So run the Flyway migration for this schema. And then we need, so the third one. So for example, this is what I mentioned earlier. So initialize the default data, and this one is optional. All right, so this one is optional. You don't need to have it, but we will prepare it. And here I will catch any exception, and then we will see what we will do when we have an exception. So here I will create a method called create schema. So creating a schema, I just need to pass the schema name. So creating the schema is so simple. So if you're good, or if you're familiar with SQL queries, so this should be very easy. So I will have a final string SQL equals string.format. So here, so create schema if not exists, and then %s schema name, and that's it. All right. So like this is, so for example, so let me show you in here. So I will create a new query for this database, like for the SaaSDB database. And here I will say, for example, create schema if not exists test. All right. When I run this one, you see that now I have the schema test. All right. Also, I can do drop schema test, and then drop schema test, and the schema is dropped. So this is this is exactly what I'm trying to do. All right. So now in order to run this query, I need to call my JDBC template.execute SQL, and that's it. All right. So this is the first step. So the first step, we created the schema. Then, so let's say afterwards, log.info, let's say, for example, schema created successfully, schema name. Now what we need to do, we need to run the tenant migration. So run tenant migration, and we need to pass the schema name. All right, so let's implement this method, this run tenant migration. So first, let's start with a log.info running tenant migration for schema. So here I will create an object of type Flyway, and then let's call it tenant Flyway. So tenant Flyway equals flyway.configure. The first thing, we need to set the data source. That's why we have to set, or we have to inject the data source. All right, and then we need to set the schema. After that, we need to set the locations. So the locations, location. So the location, it's a list of strings, as you can see in here. So you can pass one or multiple strings. So it's under class path and then db/migration/tenant. So it's under class path db/migration/tenant. I want to execute all the SQL scripts that I have in that location. All right. So, and here in the same way as we did, so the baseline on migrate, so let's set it to true. And then let's say, for example, the table, let's call it Flyway schema history, or maybe Flyway tenant schema history, or otherwise, if you do not set it, automatically it will use the default name, which is the Flyway schema history. So again, and validate on migrate, I want to set it to true because we need to validate the SQL and everything. So, and then let's say clean disabled true, and then .load. So this is the Flyway configuration. And then all I need to do is to run the migrate command, or the migrate method. So let's add a log.info in here. Let's say tenant Flyway migration started. And once it's done, tenant Flyway migration completed. So in this way we can know, or we can identify only from the logs if the migration was successful or not. So let me just resume this one. Here we just need to create an object of type Flyway, and we use the flyway.configure method, and we need to set the data source and the schema. So, and also the location. So the most important two parts is the data source and the schema. And then the location, if we do not specify it, it will automatically use the default location that Flyway knows. And then otherwise you can specify, because for our case we want to provision for the tenant this script. All right, so that's why we put it in a different place. And then baseline migrate true, and the table and the validate and so on and so forth, like the different bunch of properties. And finally, all you need to do is to run flyway.migrate, and Flyway will take care of the rest. All right, so this is the second step. Let's go up in here, and the last one is initialize. Let's call it initialize default data, and here let's pass, for example, the schema name and the tenant if you want to. So it's really up to you what you want to do, but this method I will keep it empty because, as I mentioned, so like do what you need to initialize the default data. All right, so now we need to go to the catch block. So if something wrong happens, first I will log an error. So error provisioning tenant, company name, and so on and so forth. And what I need to do, I need to roll back. All right, so roll back, this means drop the schema creation. All right, drop the schema creation. So schema creation. And then I will simply add another try and catch block. And here, let's say drop schema. And here schema name. So this is what we did exactly when we run the query. I will catch any exception. So any exception, let's call it exp. We cannot give it the name e because it's already declared in here. And let's say, for example, error dropping schema. And after that, I need to throw a new tenant provisioning exception. All right. So here, let's say only failed to provision tenant, and I don't need to pass this exception. And now let's go ahead and implement this drop schema method. So this drop schema, it's like exactly almost like this one. All right. So we can even copy paste the code from here and paste it in here. So now just drop schema if exists and the schema name. All right. So this is our provisioning service, and in this way we will be able to automatically and programmatically create a schema, and after creating the schema everything will work smoothly. So what we need to implement next is all the Hibernate parts to determine or to get the schema and set it and fetch the data only for that schema for that specific tenant. So let's go ahead and implement this one. All right, so let's go back to security and to our authentication filter. So we mentioned that we have a tenant schema resolver class that we need to implement. So I will create this class and I will create it under the config package. So this one, or this class, it should be a component, of course. So it's a component and a required args constructor and SLF for J. So the current or the tenant schema resolver is simply a class that should resolve the tenant schema. All right. And then we need to set the schema. So I will explain everything step by step. So for that, we need to inject our private final JDBC template, always from Spring Framework. And then I will create a private final static string. So static string, let's call it the public schema name. So this will be always our fallback schema equals public. So, and let me fix this one. And then what I need to do, so I need to create a public string, so a public string method, and let's call it resolve tenant schema or resolve schema. So let's call it resolve tenant schema. And here what I need to do, or what I need to pass, is a final string tenant ID as we have in here. All right. So this resolve, so we need to pass like resolve tenant schema dot tenant ID. All right. So let's go back and finish implementing in here. So the first thing, what we need to do, we need to check if we have the tenant ID or not. So if tenant ID, so tenant ID is null, simply return the public schema. Then in a try and catch block, so what we need to do, sometimes this auto completion really annoys me. So final string company code. I need to get the company code, because you remember in the provisioning service we said that the company code is the one that I want to use to create the schema. All right. So this one will be equals this dot jdbc template dot query for object. Okay, maybe the auto completion is fine. Let me just double check. So select company code from here. It should be public dot tenants. So tenants where ID equals the ID that we want to pass as a parameter, and deleted equals false. All right. So we want to pass. So the parameters are string dot class, because this is the value. This value is of type string, and here this is the parameter that we want to pass. All right. So here, just using the JDBC template, we execute a query against the public schema dot tenants. All right. So then what I need to do, if the company code is not null, so if it's different from null, what I want to do, so simply final string schema name. So schema name equals, so here let's add this one, equals tenant underscore, because in the provisioning, so let me just remind you, maybe like the code is too much. So in the provisioning service, when we provision or when we create the schema, so the schema name is always tenant underscore and then the company code to lowercase. All right. So here, so tenant, so tenant.company code dot to lowercase, and here I can add a log.debug. So tenant schema resolved. This one for example, let's say for tenant, and here I can pass the tenant ID. All right. Otherwise, and then finally, of course, we need to return the schema name. Otherwise, if something goes wrong, so let's warn in here. So just a warning, because this is really important. So tenant schema not found for tenant, for example, and here, for example, let's say using public schema. So this is not like a fallback. This will not resolve anything, but at least we know from the logs that something happened. So let's catch any exception, and if something happens, error resolving tenant schema for tenant ID, and we always, as I mentioned, fall back to the public schema. So this is our tenant schema resolver. So this is how we can resolve the schema. But there is something. So here it should be static final. Let's optimize, organize and optimize the imports. All right. So there is something. So you know the tenant ID or the schema name is not something that will change across the time, and it will not change at all, let's say. So the schema name, like once it's created, it will never change. So this means what? So if you have always static data and data that does not change, or at least does not change so often, or you know that it will not change for a period of time, always think about caching. All right. Always think about caching the results. So I will use a cacheable here. So I will cache the result. So let's give it a value. Let's call it tenant schema, and the key it's tenant ID. Okay, really nice auto completion. But here, so caching. So we have many options for caching. The best one is using Redis, but for this case we can use the Spring caching. All right, or the Spring cache. How to do that? So in here in the config, I will create a new class, and I will call it cache config. So like it's really simple implementation. So cache config, it should be a configuration, and here I will enable caching. All right. So I will create a bean and then a public cache manager, and then I simply need to return a new concurrent map cache manager. All right, and here we can provide the cache names. So let's call it tenant schemas or tenant cache as we called it in here. So the name should be the same. All right, so let's call it tenant schemas. So let me copy this and provide it in here. All right, so if you have multiple caches or you want to add another cache, just add the name to this cache config. So this is our tenant schema resolver and the tenant schema cache. So now we resolve and we cache the result. Sorry, that we cache the schema name. So now, in order to help Spring and Hibernate identify or like out of the box use the exact schema or the correct schema that we want, we need to provide two things. We need to provide a multi-tenant connection provider, and we need to provide a current tenant identifier resolver. All right. So these are two classes that we need to implement, and out of the box, Spring and Hibernate will use those implementation because by default they have their own implementation. And when you provide a bean of that type, Spring will use that bean instead. All right. So this is what we will do next. So I will create a new class in here. So these two classes, of course, like along with all what we did about like the tenant schema resolver, the tenant context, and so on and so forth, for the tenant filter and the tenant Hibernate filter, those two files or two configurations, we can of course remove them. But for now, I will create a multi-tenant connection provider. and let's say implementation, for example. All right, so a multi-tenant connection provider implementation. So here, of course, it should be a component, required args constructor, and SLF4J just for logging if we need to. And here, the important part is that we need to implement a multi-connection provider. All right, so multi-connection provider, this is a generic interface, so of type string, and we need to implement another one. The other one is the Hibernate property customizer, because we need to customize the properties, and I will show you and explain what I mean with that. So you see, we need to implement all these methods. All right, so this is what we will implement right now, step by step. So the first thing, I need to inject my private final data source. Let's call it data source. So here we have a method called getAnyConnection. So this getAnyConnection, it will retrieve any connection. So like as the name mentions. So I will use this .dataSource.getConnection. And then we have another method called releaseConnection. So releaseConnection means when, for example, when tenant A is fetching his products or categories, for example, we need to get the connection, set the connection, fetch the data, and once everything is done, we need to release the connection. So here you need to provide, so you need really to be careful like with the implementation here, because it might impact whether the database, the performance, or anything. So here, just as I mentioned, just be careful. So now this release connection, we pass the connection. So simply we call connection.close, nothing really fancy or nothing really complicated in here. So now the important method is the get connection, because you know this get connection, it will return the connection that you want to route to. So you want to route the connection for tenant A to the schema A. You need Hibernate will use this get connection. If something happens, it will use getAnyConnection. All right. So, but this is the most important method. So I will add a debug level. So getting connection for tenant and here S. So this S, I will just rename it. This is the tenant identifier. All right. And I will show you where this tenant identifier, where we get it from. So we get it from the class or the current tenant identifier resolver implementation that we will implement in just a few moments, only after this implementation. So I need to define my connection. So here instead this .dataSource.connection, I can use this getAnyConnection. Now I need a try and catch block. So first, if my tenant identifier is not null, okay, and my tenant, of course, I need the negation, and if not tenant identifier dot equals public. So if it's not the public schema, what I need to do, I need to set the path. All right. So let me show you something in here. So if I create, if I create a new query, so here let's say create schema test. All right, so this will create the schema test. So now let's create, for example, test 2. Yeah, it should be underscore. So we have test 1 and test 2. So now, for example, let's say here I will create a new table. Let's call this table prod, for example. All right, so it will be production, and let's add a colon. Let's say name, for example. All right, so let's say it's type varchar and 255. All right, so I have a table prod in here, and here this is the schema for the other tenant, for the tenant 2, for example. So I will create also a new table in here, and I will call it also prod. All right, and in the colon, let's add a colon in here. Let's call it name, and it will be a varchar. So I have the two schemas with the same tables. So here, if I say, for example, select star from prod, so from prod, this will say like relation prod does not exist. But if I say, for example, test.prod and execute it, it will execute the query. But as you can see here, I'm always tied to the schema name. How can I just execute this query without specifying the schema name? So we can do it this way. So we can do set search path equals test1 or test2, for example. So when I execute this one, and now I execute this, so it will retrieve the data. So let me show you something. I will open this one and I will insert, so let's say, for example, test1. Let's commit this one, and here I will insert another one. Let's call it test2. And let's persist this one. So now if I execute this query, it will retrieve test2 because we set the search path to test2. Now if I change the path and now execute this query, it will now retrieve or return test1. All right. So this set search path is the key to identify or to route the query to the correct schema. All right, so here let me just bring this one to public, and I can just do drop schema test2, and okay, anyways, I can do that manually, or I can do it later on, it doesn't matter. So object, and I hope this part is clear. Yeah, all right, anyways. I don't want to focus on that, but now, so this is why I'm doing this test. And here, as I mentioned, what we need to do is simply the following. So connection.create statement and then execute set search path to, or here, so we have connection.set schema. So schema here, it's only setting the schema, and this will append it as we did in the first query, right? So here all I need to do is to execute the following: set search path to tenant identifier, and then I can add something just for safety, and also public. So I set the search path to the tenant or the selected tenant, and also the public in case, for example, I need to retrieve the users, I need to retrieve the tenants. Okay, so once we do that, I will add a log.trace in here, set search path to that identifier. Now let's add a catch block. So here we will catch any SQL exception. So error setting search path, and for example, let's throw E. And finally, let's return the connection that we have in here, or that we created in here. Then we have this method. So this method is release connection. So simply let's try connection, not connection.close, but connection.create statement.execute, and set the search path to public. And as simple as that. Let's catch SQL exception. Let's add log.error setting search path, or error getting connection, or anyway, like you can add your message in here. All right. So then what do we have in here? So we have supports aggressive release. This should return false. We don't want to have that. And then we have is unwrappable as. So this also should return false, and we can keep the rest as the default, except for this customize. So this customize, we need to add this customization. So here we have the Hibernate properties, and we need to set the multi-tenant connection provider. All right. So there is a property. I don't know why this auto completion, but there is a property called, so it's in this class, it's multi-tenancy. So multi-tenancy settings dot multi-tenant connection provider. So we need to tell Hibernate what is the connection provider that it needs to use. If you implement all this without implementing this interface, this means nothing. All right, like this will not be used. And this property is the following. So whether you can pass it as a string or use this constant in here. So Hibernate.multi-tenant connection provider, and all you need to do is to pass the current class because it takes an object as a value. All right, so this is the first one. And here, because I mentioned in this method that the get connection will pass the tenant identifier as a parameter, but how Spring or Hibernate will get the tenant identifier? It will get it from this class. So here I will create a new class and I will call it current tenant identifier resolver implementation. So resolver implementation. Okay, a long name, but worth it. All right. So for this one, we need to implement the current tenant identifier resolver. And here it's a generic one, so string. And of course, we need to implement the Hibernate properties customizer. So let's go ahead and implement the method. So this one is like, it's a simple one, to be honest. So here, validate existing current session, I wanted to set true because I want to validate the session. And let's start with the property as well. So here, tenant identifier resolver, but this one I will also use the same configuration in here. So I will just type it my own. So it's multi-tenancy settings dot multi-tenant identifier resolver. So it's this one, and it should be this, like the current class. All right, so now let's come back and implement this method, the method that's called resolve current identifier. And as I mentioned, this is how we pass this parameter in here. So it's really simple. So final string, let's call it schema equals our tenant context dot get current schema, right? So as simple as that. And then of course this should be a component, not configuration, but component, and SLF for J. So here I will just add get current schema, and then log.trace, so current schema name, and then here just a check. All right, so just a check. If the schema name equals null, so if my schema name is null, I will return the public one. And then what I need to do, I need to return the schema. So why I need this check? Because, for example, because when you are connected as a platform administrator, you do not have a schema. So the schema will be named. So the current schema will be null. So you need to fall back to the public one. All right. So like this is why we need that. And with that, we are almost done with the implementation of our complete backend that supports multi-tenancy. So now if I go and register a new tenant and then log in as a platform admin and approve the tenant, this will automatically create the schema and do all this stuff. So what we will do next, we need to implement the authentication part. So like to generate a token, to authenticate a user, and so forth. And then afterwards, we will be able to test our application and see if what we already implemented is working fine or not. So let's go ahead and implement the authentication part. All right, so now let me show you the last part of our backend before we move to the front end and implement our beautiful application. So here I created a package called auth, and inside it I have the service request responses. So let's start from here. So we have a simple login request, and we ask for username and password, and of course we have all the validation. And also meanwhile, in all the requests objects, I added also the validation annotations like not blank, size, also for the product, not blank, like for all the mandatory parts. The same for register tenant request, stock movement, and user request. All right, so let's go back to the authentication. I also created an object login response, so it contains the access token and the token type. So now we move to the service. So the service contains a login method, and this login method is implemented in here. All right, so this authentication service implementation implements the interface, and here we define the login method. So here we need the authentication manager. So this is a Spring Bean, and we need to provide it in the beans config class that we created. So simply we need to create a bean of type authentication manager, and here we need to inject authentication configuration and simply get config.getAuthentication manager. And then we need our JWT token service to create or to generate the token, and the login we simply what we need to do. So here we need to call the authentication manager.authenticate, and we need to pass an object of type username password authentication token, and inside we need to pass the username and the password. So once everything is fine, and if this works, so this authenticate method will return the authentication, and this authentication we can cast it to the user since our user already implements the user details. All right, so this is why we can cast it in here, and after that all we need to do is to call our JWT token service and generate access token, and we pass the tenant ID, the user ID, and the role. So now for the token, we set the token type to bearer token and simply return this response. And here let's move to the authentication controller, which contains two parts. So the first one is the login. We simply call the authentication service.login method, and we have the register. So the register is part of the tenant service. All right. So for the tenant service, what do we have in here? Simply we ask for a registration or register tenant request. So this is the object that we have in here, and then we simply call the tenant service.register tenant with the logic that we already implemented together previously in this video. So this is the authentication part, like it's classic one, nothing really fancy, and I hope I did not skip anything. So now all we need to do is to start our backend application and go to Postman and try to test a flow for our application. So there is one thing that I forgot to implement before we move on. So here, if you remember, in the abstract entity, we have the updated by and created by, and we need to grab this from the security context. So in the config in here, I will create a new class and I will call it JPA auditing config, for example. So JPA auditing config, and then all I need to do is to add configuration in here. And now we need to provide a bean of, so it's going to be public auditor aware of type string, since our ID is of type string, and let's call it auditor aware or auditor provider, for example. So auditor provider, and here we need to return a new auditor aware. So in order to do that, we simply need to create or to implement a class. So I will have the class as a public static class, and it will be auditor aware implementation implements auditor aware. So let's implement the method in here, get current auditor, and for this one, so now we can just say return new auditor aware implementation. So let's implement this one really quick. I already implemented that few times, but it's okay, I can do it again. So here I will get the authentication. So let's call it authentication. I will get it from the security context. So here I need to make a first check if my authentication is null or my authentication is not authenticated. So here is authenticated, and I have the negation in here. So or authentication get principal equals, so null or equals anonymous. All right, anonymous or anonymous user. So in this case, all I need to do is to return optional.empty, or well, let's say just empty, because we want it to fail. Otherwise, if not, so here if I have authentication dot get principal, not instance of string, but if this one is not null, simply all I need to do is to return an optional dot of authentication dot get principal. So here what I can do the following. So I can cast the result to string, and then authentication dot get principal. The principal will be the user ID. Otherwise I simply return optional dot empty. And also don't forget something which is really important, that you go here to the application where we have this enable JPA auditing, and here we need the auditor aware ref. All right, we need to pass the auditor aware ref, and here it needs to be the bean name. So let's copy this method or the bean name from here, and we pass it here as a parameter. So now I think we have all the blocks. So the next step, we will start the application and we will try our API and see if the schema is getting created, and we can implement and we can isolate data and so forth. All right, so now let's go ahead. So here what I did, I removed everything from here, also removed the two schemas that we created, the test and test 2. So now I will start the application, and let's start with our first test. So let's make sure that everything works fine. So the application started. Let's check the database, the public schema, and we should have here 3 tables: Flyway schema, tenant, and users. All right, so now what we need to do is simply go to Postman. So I prepared a collection in here. So first thing, we need to register a tenant. All right, so I will here, so we have the just information, like I did nothing really fancy or something out of the box, but just ChatGPT generated this information for me. So I will click on send and see what will happen. All right, so we have a 403, but this API or endpoint should be public. So let's go ahead and check what is the issue. All right, so created by relation for tenants does not exist. Okay, so I guess I know what is the problem, because in here, when we init the tenants, so what do we have in here? So for the tenant, we have created at, updated at, and we have, yeah, so we don't have the created by and the updated by, because we do not need this information, because this is kind of a public table. So how we can fix that? So I will open my tenant entity. So let's go to entities in here. So let's open the tenant, and the problem is the tenant extends already the abstract entity, and this is not something that we want to do. So I will copy the ID from here, and then I will remove this extends, and I will have, or will paste the ID in here. So now we have all this information. We can also add, so let's copy the entity listeners and the created at and updated at. All right, so I can put this in the bottom, and let's add the entity listeners in here. So now let's just stop the application, remove completely the tables, and here let's say drop, and now I will restart the application, and now this should create deleted. All right, so okay, we can also copy the deleted field, so this is completely fine, and let's add this one in here. So now let's restart the application. Okay, so if I refresh, here we have the tables, and now let's go back and try to hit the same endpoint to register a user. All right, so send again, and now we have 200. So here, if I open the tenants table, so we see that we have the tenant just getting created. So for that, just for the sake of testing, I will copy the admin password and go to the users. So here for the user, I will create a new user. All right, so I will say deleted false, enabled true, created at, let's say today, updated at null, created by, let's say system, for example, if you want to, and the email, let's say buali.ali@mail.com. So first name is Ali, and the ID I will generate a UID, and for the last name, let's say Buali. I will create the admin, the platform admin, right? So let me open the user role. So here user role, and I want him to be a platform admin. So let's get back here. So this is the role. Tenant ID can be null and updated by, and the username, let's say Alibu, for example. All right. So Okay, so I need to generate an ID. Let me ask ChatGPT to do that for me. All right, so this is my ID. Let me try to save. Yeah, so here it should be role_platform admin. Okay, so now we have our admin user. We will use it later on to authenticate and approve our tenant. So here, let's go in here. So we have I want to show you something. So you have our controllers and we have the category controller, and I think we missed or forgot to add the tenant controller and user controller. Let me add that quickly and get back to you. All right, so I implemented, quickly just exposed the methods that we already have for tenant and user. So here we have tenant controller, so it's /API/v1/tenants, and I injected here my tenant service. And then I have the method to approve. So approve a tenant. We have also activate, deactivate, suspend, and find all tenants. All right. So then the same for user controller. So here to create a user, only company admin can create a user, and forget all users, only company admin and administrator. The same for get user by ID. Update user, it should be only company admin. Delete user, only company admin, and for delete and enable and disable. So we can also adopt the same for tenant. So here, for example, for approve, let's say here it should be platform admin and all of them. So actually all this controller is only for the platform admin. So we can put the pre-authorize on the controller level or the class level. So let's restart the application, and then we should be able now to log in or list the tenants and so forth. So let's get back in here, and I will create a new endpoint and I will call it get all tenants. So this will be our HTTP localhost. So instead of auth, so it's gonna be tenants. And now before that, we need to log in our user. So here it will be BoAli as a username, and then I have a post script. So it only saves the access token as a global variable, so I can use it later on. All right. So let's try to send now. So we have a 401, which is unauthorized. So maybe the login or password is incorrect. So let's double check. Do we have any exceptions here? So we have bad credentials. So let me check the username. Where is my username? So it's Alibu. Yeah, of course. So let's click on send, and now we have 200. Okay, and we have our token. All right. So now our token, thanks to this post script, is now available. So here, if I go to get all tenants, and here in the authorization, I just say it's a bearer token, and I can pass my access token or my bearer token in here. All right. So if I try to access get all tenants, it retrieves or it gives me back the list of the available tenants. So this is my tenant ID. Now I will try to approve it. So here, let's just double check that here we don't have any exception. I will just clear the console. And here I will approve my tenant. So I will paste the tenant ID in here and click on send. So we have a 403. This means, okay, so token has expired. Yes, of course. So because it needs to be my access token. So let's clear the console in here and click on send again. So we have 200. So now if I go back in here and refresh my database, I should see that I have a new schema getting created. So now if I list the schemas, so we have the tenant Technova 001, because this was the company code that we used in here to register our tenant. So the company code is Technova _001. And now if I open this one, I should see that I have all the tables, the categories, and so on and so forth. And then if I go to the users and refresh the table in here, we should see that the user that was created for that tenant ID. So For now, everything seems to be working fine without any issues. We are able to create the schema, and of course, like the rest is simply an API, but let's give it a try. So now I will log in this user and I will try to create a category, for example. So I will paste this one in here, send. So wait, what was the password for this tenant? It was password. Let's double check. All right, so maybe there is something wrong. Yes, so it's set enabled to false, so I will set it to true here, and I will approve, and the fix, I know where it is. So it's in the user service. So if we go to services and then user service implementation, and when we create the user, of course we need to enable it, because by default it's disabled. So it's up to you, like whether you want to enable the user or simply set it enabled by default. So I will close everything, and now if I send again. All right, so now if I log in again my tenant user, so the user that belongs to the tenant, so we have the token in here. So now we can, for example, create the category. So what we do in here, so for the authorization, I will also set it to authorization, setting the access token, and the body is in here. So let's say, for example, category 1 beta. So let's keep it this way. It's completely fine. So here, do we pass something wrong? So we have 403, let's double check. All right, so relation categories does not exist. So this means that we are not able to set the schema, or at least to extract the schema. So let's add a point to our authentication filter. So from here, let's add a breakpoint and let's send again. All right, so let's double check. So here we have the user ID, the tenant ID, and the role. And now tenant ID is not null. So we set the tenant ID in the context and we get the schema. All right, so the schema is always returning public. And we are not hitting the resolve tenant schema, even though I have a breakpoint in here. So I know why. I think it's because of this cacheable. All right, so let me just restart the application to get rid of the cached values, and let's try once again. So if I hit send, so now I can just skip this. All right, so now we have the tenant ID, and let's try to check. All right, so here error resolving tenant schema and view. Okay, there is an SQL grammar exception. So let me stop the application and fix. So this one is false, and let's try select company from tenants, not tenants. All right, so it's tenants. Okay, I hope this fixed the issue and we don't have any other SQL grammar syntax. So if I hit send again, and now, so here, okay, so now we get the company code, and now everything should work fine. So I can remove these two breakpoints, and now we have the category. So if I double check in here, so here we should see one inserted line. What I will do, I will go to register tenant and register another one. So let's say contact to Alibu, and let's go hit send. So this was created. So if I double check the tenants, I have my second tenant. So I will again log in with my admin or platform admin. The username, I think it's Alibu. Yes. And now I will get all the tenants, and this is my new tenant. So I will copy the ID from here, and I go to approve tenant, paste it, and hit send. So 200. So this means that if I refresh in here, I should see 5 schemas right now. Exact. So this is my new tenant schema. And now I see, for example, so this is the first one and this is the second one. So now just to test the isolation, what I will do. So my user in here, so the user that I have for the new tenant, first let me enable that user. And the username is called ali.bu if I'm not wrong. All right, so I will log in with this user, send, and then we have the token. So now if I create a category, or at least maybe let's try the get all categories. So now for that user, it returns empty because in this new schema that we have right now, we don't have any categories inserted. So if I create a category, let's say, for example, computers or phones or whatever, and I hit send, so this should create. And now if I do get all categories, this should return only computers. And of course, we can double check the database, and now we have our computers category inserted in the correct schema. So in this way, we just implemented the complete backend. So now all we need to do is to create a front end and make it look nice in order to have our application up and running end to end, like from the backend up to, from the front end up to the backend. And in this way, you ensure that you have a complete working SaaS application that supports multi-tenancy. All right, guys. So for the front end part, I did not want to record it, to be honest, because it will take so long just to write HTML and CSS and some TypeScript logic. So I will just, I already did that multiple times. I have like so many Angular applications in my YouTube channel, so you can follow any of them. And I followed the same steps and the same coding style and the same coding approach. So let me just first explain to you what do we have here. So of course, as you know, I do not write the services myself. I just copy paste the OpenAPI specification in here, and from the package.json here, what do I have? I just created this command, this new command, to automatically generate the services. So OpenAPI gen, of course, we need the OpenAPI generator dependency in here. So I don't want API services true, promises false, input, and so on and so forth. I already mentioned that, and I already explained that before in multiple videos. So just go ahead and check that. So after that, how did I decompose my application? So I created mainly 3 or 4 main folders. So here API services, so this is the generated services. And here I have the core where I put the guards, the interceptor, and the token service. So this is the token service where I can store my token, extract information from the token. And I have the interceptors, and mainly have an HTTP interceptor to check if the user is already authenticated or not. And for the guard, I have 3 guards: so an authentication guard, platform admin, and tenant guard. So authentication, just to make sure that user is authenticated; the platform admin, to make sure that only the pages that should be accessible by the platform admin are accessed by the platform admin. The same for the tenant. And then what do I have next? I have features, and before that I have the shared, and here I just have few models like the error response and the validation error. And here I have the features. So for the features, I have here admin, public, and tenant. So the admin is the part where the admin can manage the list of tenants, and he has the admin dashboard. And then I have the public one where I have the home page, the login, and the register page we saw in the we will see in the demo a few moments later. All right, and then we have the tenant, and for the tenant we have the category list, dashboard, product list, statistics, stock movements, and user list. And inside each list we have the manage. So for category list we have manage category, for product list we have manage product, for stock movement we have manage stock movements, and the same for user list. And the rest, to be honest, is just like classic HTML and CSS and TypeScript code. So as you can see, for example, here to create for the list of categories, all I need to do is to inject the right services like category service, message service to display the pop-ups, and here simply loading the category using the pagination, so where I pass the page and size as we implemented it in the backend. And here, like, look at this HTML. So the list is simple, but let's have a look on the manage category. So here we see that this is the code to manage the categories. We have also the same one. So like this is why I did not honestly, I felt a little bit lazy to record all that, so I just implemented it and I wanted to showcase it for you. So the implementation is really simple, and also all the code is available in my GitHub repo. All you need to do is to search for SaaS App UI, and then you will find everything available for you there. So as I mentioned, nothing really special, nothing really custom. So I just made it a simple web application or a simple Angular application. And also in here, so for example, you have the app.ts and the app config.ts, where I configure my interceptors in here, and I used PrimeNG as a UI framework, and this is the configuration of PrimeNG to set the theme and the preset that I want to use. All right, so now with all that being said, we can move on and check the demo of our application. But before we do that, I just want to remind you that if you are not yet subscribed, just go ahead and subscribe and do not miss amazing videos and like top-notch implementations and tutorials that I'm publishing every week. So also drop a comment and hit the like button. And now let's move to the demo of this application. All right, so let's check together the output of this application. So here our landing page. So it's a multi-tenant stock management platform where you can manage inventory at scale. You can start a free trial or sign in if you already have an account. So everything you need to run your business: product catalog, stock movement, team, and roles. So if you do not have an account, just click on get started or start your free trial in here. If you already have an account, just click on sign in. So here from the sign in, if you are, for example, if you log in as a platform admin, so you will be redirected to a dedicated interface where you can see the list of tenants, the status, all the information about it. You can deactivate, you can suspend the tenant, and do everything you need about tenants. So now if we log out and create a new account, so let's say, for example, CMP comp, for example, or Alibu CMP. Let's call it this way. And here, let's say, for example, Alibu_CMP. So the company email, let's say contact@cmp.com. Let me copy this one. And here, let's say John Doe. And here, let's say john.doe at, I don't want to allow this. And the password, let's say simply password. So now let's click on create account, and the account was created. So if I log in again as the platform admin, so and here password, and I click on sign in. So all right, so we see here that we have the Alibu CMP or the new company listed in here. Once I approve this one, a new schema will be created in the backend. So here we see that we have 5 schemas. And also, like, I can remove or delete the old ones, but let's see the list in here. So we have the public, tenant, Technova 1 and 2, and these are the default or the Postgres schemas. So now if I approve this one, so we see that tenant approved successfully. And now if I refresh, I should see 6 schemas. So now I should see the tenant Alibu CMP. So now all I need to do is to connect with my new username, or the admin of the platform, so which is john.doe, and then I have password, and now I'm logged in as the new company. So if we check here, so here we have our dashboard. So like we have an inventory overview with the number of products, categories, stock movements, the low stock alerts, and also some movement trends, and the top categories, and also quick actions from here. So for example, I can create a product, manage categories, record movements, and add users. So if I go to products, so for now we don't have any products available, but first we need to create the category. Let's go here and say electronics, for example, and here let's say also electronics for the description. And now I will create a new product. Let's select electronics, and let's say MacBook, and here let's say maybe MacBook Pro as a reference. So here let's say maybe MacBook Pro, and the price, let's set it to 7,000, and the alert threshold, let's say 2. Let's create the new product, and we have the product just getting created. We can update it, we can delete it, we can do everything we need. So next we move to the stock movement. So we see how here we have our MacBook, so we can record our first movement or other movement. So like both of them, they point to the same option. So here we can also drag and drop the pop-up in here. So let's add some quantity, let's say 10, and the nodes, let's say maybe import or purchase or whatever. Now, for example, in case I want to sell one laptop, so it will be of type out, let's say 1, and let's say maybe sale. And here we see it's of type out. And then we can also manage the users. So here we see all the users that belong to this company or to this tenant. So I will create a new one and I will give him the role sales operator, for example. Let's call him, for example, Ahmed, just a simple name, and then Ahmed at cmp.com. And let's give him a username. So let's give him just ahmed.cmp or sales.ahmed, for example, and a password. So let's create the user. And now we see that we have the user just getting created, and here all the information and the role. We can update the user, of course, and we can do everything we need. So now if I try to connect, let me copy the name from here or the username. So if I log out and connect using this new user, so the user can access the interface and he can see the list of products and categories, stock movements for that tenant. So no one can access the information or the data of another tenant. So he can see the list of more stock movements, the categories, he can create categories, and so on and so forth. Of course, depends on the role and the permissions that that user have. All right, so this is it. And I hope you enjoyed what we built together today. And of course, don't forget to hit the like button, subscribe if you're not yet subscribed, and of course, drop me a comment and tell me what you want to see next. Thank you so much for watching and see you in the next one.